Before a star ever shines, there is a moment so quiet, so impossibly soft, that the universe seems to hold its breath. A moment when darkness gathers itself like a blanket, when dust drifts in slow spirals, and when the faintest suggestion of warmth begins to hum beneath the cold. Every star you've ever seen, including the one that lights your days, began in this silent cradle, hidden inside a cloud where time itself moves gently, and tonight we drift into that beginning. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing find its rhythm, and your mind float through wonder. Before we begin, I'd love to know where you're listening from. Are you lying in bed under city lights, or watching the stars from somewhere quiet? Tell me in the comments. It's always peaceful to imagine the AstraFlow community scattered across the world, drifting together through the same sky. And if this calm journey brings you peace, you can gently support AstraFlow by liking this video or subscribing. It helps this little corner of the cosmos keep glowing. Now, sink into your pillow, soften your shoulders, and let your breath fall into a slow, steady flow, in and out. Tonight's voyage is not a race, but a quiet drift into the story of how light is born. When we look up at the night sky, we often see stars as fixed points of brightness, distant, patient, unchanging. But every star once lived a life without light, a life inside a cloud of dust and hydrogen so thick that even starlight couldn't pass through. Imagine floating inside such a cloud now, cool, dim, silent. Tiny grains of dust suspended like a cosmic mist, each one older than Earth, older than the sun, older than every story humanity has ever told. In this dark ocean of drifting particles, nothing seems to move quickly. The airless silence carries no sound, no breeze, no heartbeat. Yet gravity is always working here, gently, invisibly. It draws the cloud inward, grain by grain, atom by atom, gathering the seeds of something that will one day shine. There is no rush, no urgency, only patience measured in millions of years. As you breathe, imagine these particles drifting closer, flowing in slow spirals the way your thoughts do when they begin to settle before sleep. A star is not born through force, but through steady, quiet accumulation, a long exhale from the universe itself. This is the story we explore tonight. The story of how stars emerge from darkness, how heat grows inside cold, how light ignites from silence. It is a story far older than Earth, and yet intimately connected to you. Because the atoms in your body were once warmed in these very kinds of clouds, so let your awareness soften. Feel the slow pull of gravity guiding your mind inward, toward a place of stillness. You are floating through the origins of light now, drifting beside the first warm glow that hints at a star to be. Now, let's begin tonight's voyage into the quiet story of how stars are born. If you close your eyes for a moment, you might notice how darkness isn't really empty. It has texture, tone, and a quiet presence of its own. In the vastness of space, darkness works the same way. It isn't a void, not a blank canvas, it's a waiting place. And inside that stillness, a question rises softly, like a whisper drifting through a cold cosmic sea. Where does light begin? How does something brilliant, warm, and life-giving emerge from a place so silent, so far beyond our reach? It's a question older than human language, a question that ancient skywatchers once felt deep in their bones as they stared at the stars and wondered about their origins. And even today, with all our telescopes and equations, the heart of the question remains poetic. Light begins where the universe allows itself to gather, where gravity breathes in and matter leans inward, where dust and gas surrender to a slow collapse that no one can hear. Light begins in patience. Imagine drifting through a giant molecular cloud, a cradle of hydrogen and dust stretching for dozens, sometimes hundreds of light years. From afar, it looks like a soft shadow against the deeper dark, but inside it is a world of floating particles, each one shimmering faintly under the influence of nearby stars. These clouds contain the raw ingredients of creation, scattered like flour before a loaf has ever been shaped, waiting for the quiet hands of gravity to begin kneading. The question, where does light begin, becomes more than scientific. It becomes a meditation, because the answer is not sudden, is not loud. It is not a spark that leaps into existence with fiery drama. Instead, it is a slow inward turning, a gradual embrace, a long invisible gathering that builds heat in the coldest places. Perhaps you feel this rhythm in your own breath, a gentle expansion and an equally gentle release. Light begins the same way, with something drawing in, something settling, something finding its center. Gravity gathers the cloud, cooling it further, allowing atoms to drift closer. Over time, tiny fluctuations, in places a little denser than the rest, begin to win the quiet competition of attraction. They pull in more material, they thicken, they deepen, and slowly, softly, they become something new. And there, hidden in a fold of darkness, a future star begins as nothing more than a slightly warmer knot of gas. The kind of warmth you might feel from cupping your hands together on a winter night. Faint, subtle, yet unmistakable. It is not light yet, just the promise of light. As you breathe, imagine hovering near this forming core, wrapped in a silence so complete it feels like floating underwater. Nothing moves quickly here. Even time seems to slow, stretching into lazy arcs. But the question remains, humming gently. Where does light begin? And the universe answers, simply, here, in stillness, in gravity, in the patient gathering of darkness becoming warm. Let that idea settle in you like a soft weight on your chest, comforting, steady. Because every star that has ever lit the sky began this way, and so did the atoms in your body. Light begins in places that seem quietest of all. If you were to drift deeper into a stellar nursery, you'd find that the universe hides its most beautiful beginnings inside what looks, at first, like emptiness. Dust, tiny grains no larger than the particles that settle on a windowsill, fills these regions so thickly that starlight cannot pass through. But this dust is not ordinary. It's ancient, enriched by the ashes of long-dead stars mixed with frozen gases and carried for millions of years through quiet galactic winds. And within this haze, the story of every future star is written in delicate, drifting strokes. Imagine floating among these grains now, your body weightless, your breath slow. They shimmer in faint, scattered light, like mist catching a faraway lantern. From the outside, these clouds appear as dark patches in the sky, silent silhouettes against the Milky Way. But from within, they are alive with potential. Hydrogen molecules drift like soft fog. Carbon and oxygen cling to icy surfaces. The temperature is colder than anything you've felt. Colder than deep winter. Colder even than liquid nitrogen. Yet this cold is essential. It allows the dust and gas to cling together. It slows everything down until the universe can begin its long, deliberate work. In this stillness, gravity begins to whisper, not loudly, not in a pulling motion you would feel, but in a soft encouragement, nudging particles closer piece by piece. As the dust thickens in certain places, those regions become just a little heavier, and that tiny difference is enough to begin a cascade. More dust gathers, more gas settles, a barely noticeable knot forms, invisible to the eye, but destined to become something extraordinary. It's humbling to imagine that every brilliant star you've ever wished upon once looked like this, a dark pocket hidden inside a quiet cloud, with no glow, no warmth, no sign of the fire it would one day hold. The early universe created these first seeds of dust, and every generation of stars has added more. When a star dies, gently as a red giant or explosively as a supernova, it scatters its elements back into space. Over billions of years, this material mixes, cools, and gathers into clouds like the one you're drifting through now. So the dust is not dirt, it is memory of ancient suns, memory of light that once lived, memory of elements that now flow through you. Calcium in your bones, carbon in your breath, iron in your blood. In these clouds, those memories wait for new form, and when gravity pulls them inward, the story begins again. Let yourself picture this slow swirl of dust, moving with the gentlest of motions, as if the entire cloud were breathing, in and out. You drift with that rhythm now. Nothing needs to hurry. Nothing needs to take shape before it's ready. The universe waits patiently, and so can you. Somewhere inside this dim, drifting envelope, a new star's first chapter is preparing to unfold. But for now, everything remains quiet. A story hidden in dust, waiting for its warm beginning. If you listen closely to the universe, not with your ears, but with your imagination, you might sense a faint, steady hum woven through the darkness. It isn't a sound, but a presence, a calm, ancient rhythm, and much of that quiet pulse comes from the simplest element in existence, hydrogen, the first atom to appear after the Big Bang, the building block of galaxies, and the soft cradle in which every star begins. As you drift deeper into the molecular cloud, notice how hydrogen surrounds you like a gentle fog. Each molecule is incredibly small, almost impossibly light. And yet, there are trillions upon trillions of them here, filling vast stretches of space. From far away, these clouds seem empty, but within them, hydrogen molecules cluster into long, delicate filaments, stretching like faint threads across the cold dark. They are the silent backbone of star formation, the soft foundation from which something luminous will rise. The airless chill is profound here. Temperatures drop so low that they stop feeling like cold at all and become something quieter, a stillness that settles around you like a weightless blanket. This coldness is not hostile, it's protective. It slows the motion of hydrogen molecules just enough that gravity can begin its patient work. If the cloud were warmer, molecules would rush and scatter too quickly, slipping through gravity's fingers like sand. But here, in this cosmic winter, they linger, they wait, they gather. Try imagining one small knot of hydrogen forming somewhere nearby. Nothing dramatic, no swirl of energy, just a gentle thickening, like a breath held a moment longer than usual. Over thousands of years, that knot becomes denser. It begins to pull in nearby particles. A slow drift turns into a soft leaning inward, and the core grows heavier by the smallest degrees. And hydrogen, so simple on its own, becomes extraordinary in numbers. When enough of it gathers, it creates pressure. When pressure builds, heat rises. And when enough heat accumulates at the centre, something remarkable will occur, the beginning of fusion, the ignition of light. But for now, fusion remains far away. The hydrogen cloud is still drifting, still cooling, still finding its form. The star-to-be is nothing more than a whisper inside this softness, a fragile possibility surrounded by billions of tiny molecules. There is a gentle metaphor in all of this. Even the simplest things, given patience and time, can become radiant. The universe begins its brightest creations with the quietest material. It doesn't rush. It doesn't force. It simply lets gravity guide the way. As you breathe in this moment, imagine hydrogen molecules drifting past you like tiny points of fog, each one a seed of future light. They move slowly, calmly, as though the entire cloud were inhaling and exhaling in a rhythm matched to your breath. In and out, in and out. This is the soft cradle from which stars are born, a place where simplicity gathers into complexity, where cold nurtures heat, and where silence prepares the foundation for brilliance. You drift here a little longer, feeling the calm weight of hydrogen all around you, knowing that somewhere within this vast, gentle cradle, a star's first breath is beginning. The birthplace of a star is colder than almost anywhere you could imagine. Colder than Pluto's shadowed craters, colder than any winter night on Earth, colder than the deepest, quietest ocean trench. Temperatures fall to just a few degrees above absolute zero, where motion nearly stops and molecules drift with the softness of dust caught in moonlight. And strangely, it's in this profound coldness that the universe sets the stage for heat, light, and life. At first, this seems like a contradiction. How can something as hot as a star begin in such an icy cradle? But the cold plays a gentle, essential role. Imagine holding a snow globe in your hands. When everything inside is still, flakes settle easily. When shaken, everything scatters. The cold keeps the cloud still. It slows down every particle until gravity, patient, silent gravity, can finally gather them together. If these clouds were warm, hydrogen molecules would jostle and push each other away. They'd move too quickly for gravity to take hold, but in this frozen tranquility, they drift more slowly than falling feathers, gliding through the dark with a kind of cosmic grace. Their quiet pace allows tiny differences in density to matter. A slightly thicker patch of gas becomes a place where more material can settle, and once settling begins, gravity amplifies it, guiding the cloud inward like a slow inhale. Picture yourself floating through this coldness. It doesn't sting, it doesn't bite. It feels more like a deep hush, a comfort, a silence that lets your thoughts settle gently. The molecules around you move so lazily that it feels as though time itself has unspooled into long, slow ribbons. Every moment is stretched, every drift is soft. The beauty of this cold is that it reduces chaos. It calms the cloud. It brings order to movement. It allows structure to form where none could exist before. For a star to begin, the universe must first create a place where things can come together without being torn apart by motion. The cold does precisely that. It lets matter gather without scattering. As regions of the cloud cool further, they radiate away heat in the form of faint infrared light, invisible to the human eye but constant, like a soft sigh into the dark. This cooling enhances collapse, drawing more gas inward, allowing the embryonic star to grow more defined. The colder the cloud, the more easily it can contract, and the more gracefully a new star can form. There's a gentle poetry to this. Warmth is born from cold. Light arises from darkness. The most radiant objects in the universe begin in the quietest, dimmest corners of space. As you breathe slowly, imagine this cold not as a harsh sensation, but as a settling calm, a deep reset, a stillness that prepares everything for transformation. The cold of a stellar nursery is like the pause before a breath, the quiet moment before dawn, the space where potential gathers. Soon, gravity will tighten its embrace. The cloud will begin to collapse more noticeably, and deep inside, a warm center will emerge, the earlier sign of a star's heartbeat. But for now, everything remains peaceful, suspended in the serene, necessary cold where stars begin their long journey toward light. If you stay very still, you might feel the sensation of being gently drawn inward, not tugged, not pulled sharply, but encouraged, coaxed, invited toward a center you cannot quite see. That soft motion mirrors what happens inside a stellar nursery when gravity finally begins its long, patient work. Nothing about this process is sudden. Nothing is loud. Gravity is the quietest sculptor in the cosmos, shaping stars with movements so slow they almost feel like dreams. Imagine drifting in the middle of the cloud now, surrounded by hydrogen, dust, and the faint shimmer of ice-coated particles. Everything around you is suspended in near motionless calm. But hidden underneath this calm is gravity, subtle, persistent. It doesn't shout. It simply waits for the tiniest imbalance. One region becomes slightly denser than the space around it, perhaps by no more than a handful of particles clustered together. And in the cold, this slight difference is enough to begin a change that will last millions of years. You wouldn't feel the pull directly. It's far too delicate. But if you watch the cloud with the patience of a mountain, you'd see the slow drift of material moving inward, grain by grain. Dust that once wandered freely now curves gently toward the forming center. Gas that once drifted without purpose now begins to spiral. Everything leans inward, as though answering a soft invitation. Gravity's strength is not in force, but in inevitability. Once the collapse begins, the cloud cannot help but yield. It's similar to how a thought might slowly draw your attention during quiet moments at night, not loudly, but steadily, until you find yourself drifting into it. The cloud drifts too, gathering itself into a tighter shape. As material accumulates, the center becomes denser. Pressure rises, though not yet enough to create light. The heat is faint, nothing more than a whisper of warmth in the vast cold, but it is real. A seed of a star is forming hidden deep inside this newly contracting core. As you breathe, imagine yourself floating at the edge of this slow descent. With each inhale, feel the cloud expanding gently around you. With each exhale, feel the faint inward pull. Subtle, rhythmic, like the universe breathing alongside you. Collapse and calm aren't opposites here, they are partners. The cloud is not falling apart, it is falling together. As the collapse continues, the shape of the cloud changes. Filaments stretch, knots deepen, swirls become more pronounced, but everything remains soft. Even when turbulence stirs the gas, it moves like the slow turning of underwater currents, drifting more than pushing, folding more than colliding. There's something comforting about gravity's role in this story. It doesn't choose favourites, it doesn't rush, it simply gathers what is already there, helping it discover its own centre. You might feel a hint of recognition in that idea, the way people too sometimes gather themselves slowly, quietly, finding their centre over time. Inside the cloud, a warm heart is beginning to form, not bright enough to shine, not hot enough to ignite, but growing steadily, shaped by the quiet pull that brings everything closer. In this softness, you drift a little deeper, feeling the calm certainty of a star's earliest heartbeat beginning to rise. As the giant molecular cloud continues its slow inward drift, something gentle and remarkable begins to happen. The collapse does not lead to a single point, a single star, or a single destiny. Instead, the cloud starts to break into pieces, not in an explosive way, but in a quiet, organic unfolding, the way a sheet of silk naturally forms soft folds when it settles. These folds, these subtle pockets of density, become the seeds of many stars. One cloud becomes a family. Imagine floating above this vast region now, watching the slow choreography unfold beneath you. The cloud looks like a dark, drifting ocean, full of ripples and eddies. As gravity pulls inward, certain areas gather material more efficiently than others. They grow heavier, denser, and because they are heavier, they draw in even more gas. A feedback loop begins, one that deepens the fold and strengthens its quiet pull. Soon, the cloud is no longer one structure, but many. Dozens, hundreds, sometimes thousands of small contracting knots. Each knot is a potential star. Each knot carries its own timeline, its own future brightness, its own quiet journey toward light. And all of them began together in the same shared cradle of hydrogen and dust. This fragmentation is one of the universe's softest forms of creativity. Rather than forcing one star to form, the cloud allows many. The diversity of stars, tiny red dwarfs, glowing suns, massive blue giants, all arises from these early splits. A single cloud becomes a nursery for a glittering cluster that will shine for tens of millions of years. As you drift among these forming pockets, you might notice how peaceful the process feels. There are no sharp boundaries between one future star and another. The regions blend into each other like gradients of watercolour. Only density decides where one begins and another ends, but the transitions are soft, like the edges of a dream you remember only faintly. There is a gentle metaphor here. Even shared beginnings can lead to uniquely different paths. Whether in people or in stars, the environment may be the same, the origin shared, but what grows out of it will take its own shape. There's comfort in knowing that the universe celebrates this variety. It doesn't mould every star to match. It lets each pocket of density find its own rhythm, its own timeline, its own glow. In some regions of the cloud, a knot may form slowly, patiently gathering mass over millions of years. In others, collapse happens more quickly, creating brighter, hotter stars that will burn intensely but briefly. And in the spaces between these forming stars, more dust will collect, more gas will drift, and perhaps one day, planets will coalesce in the leftover material. As you breathe in, imagine the cloud expanding around you, vast, cold, full of potential. As you breathe out, imagine those pockets pulling inward, forming boundaries of gravity where none existed before. Each breath becomes part of the cloud's slow reshaping. You drift through this nursery, watching destinies branch softly. One cloud becoming many lives, many lights, many futures, and each pocket of darkness now carries the faint, warm promise of a star that will, in time, learn to shine. Deep inside one of the cloud's densest pockets, something faint and beautiful begins to emerge. Not light, not yet, but the very first hint of warmth. It's a glow you wouldn't see with your eyes, a glow that doesn't shine outward, but instead builds quietly at the centre of the collapse. This is the birth of a protostar, the stage where a star exists not as a flame, but as a warm whisper wrapped in darkness. Imagine drifting through the cloud until you reach this forming core. The surrounding gas grows thicker, the temperature rising ever so slightly as gravity tightens its embrace. The change is delicate. You wouldn't feel the heat on your skin. It's still far colder than any room on Earth. But compared to the deep freeze outside, this tiny warmth is the first sign that something new is taking shape. The protostar doesn't shine because nuclear fusion hasn't begun. There is no fire, no flame, no brilliant glow piercing the dust. Instead, the warmth comes from compression. As the cloud collapses inward, the gas at the centre is squeezed, and that squeezing releases energy. A soft, gentle heating, like the warmth of a stone left in the afternoon sun. This is light before light, the earliest breath of a star that has not yet learned to burn. You can imagine this forming core as a dim ember buried deep inside a blanket of dust. From the outside, the cloud remains dark. Even powerful telescopes see these regions as silhouettes, shadows carved out of starlit backgrounds. But hidden within, the protostar stirs. It rotates slowly, gathering mass. Material falls onto it in a gentle rain of gas and dust, building its body layer by layer. As you breathe slowly, envision those drifting particles spiraling toward the core, pulled inward by gravity's tender insistence. Each grain of dust, each molecule of hydrogen carries memory. the memory of ancient stars that lived and died long before this one began. And now, all that memory is being woven into a new form. The protostar is wrapped in a cocoon of darkness, insulated by layers of gas that keep its warmth trapped. The outer surface remains cold, even as the interior grows hotter. It's like watching a seed underground, swollen with life but hidden from sight. All the signs of something magnificent are there, just not visible yet. The rotation of the protostar gradually flattens the surrounding material into a disk. Some of it clumps together, some of it will become planets, some will drift for ages, but the core itself keeps growing, pulling in more and more material. Its temperature rises quietly, steadily. A journey toward fusion has begun, though the destination is still far away. There's a softness to this stage, a kind of cosmic privacy. The universe allows stars to begin their lives quietly, unseen, protected in their cradle of dust. Light comes later. For now, the protostar is content with warmth, with gathering strength, with preparing for the moment when its heart will finally ignite. Drifting beside it, you feel that warmth too, faint, gentle, but full of promise. The first hint of a glow that will one day shine across galaxies. As the protostar grows, a quiet rhythm begins to shape its surroundings, a slow, subtle spin, barely noticeable at first, then gradually becoming the heartbeat of the entire forming system. This rotation is not something the protostar chooses, it is inherited. A gentle motion carried from the original cloud, preserved through collapse, becoming more pronounced as the core tightens and draws material inward. In the calm darkness of the stellar nursery, this twirl is the first true sign of structure. Imagine drifting above the forming star now, watching the rotation unfold beneath you. There is no turbulence, no chaotic swirling. Everything moves with the soft grace of underwater currents. Dust and gas spiral around the growing core, forming elegant arcs. These arcs flatten into a disk, a thin, luminous sheet of material spinning slowly around the protostar like a halo. The universe is shaping a foundation, not through force, but through gentle, consistent motion. Conservation of angular momentum, a law of physics, guides this transformation. But here, it feels more like the universe honouring a rhythm it began long ago. As the cloud collapses inward, it spins faster, the same way a figure skater turns more quickly when they draw their arms in. Only here, the dance takes millions of years, every revolution stretched into long, patient spirals. If you could reach out your hand, you might feel the faintest suggestion of motion, a soft drift, a slight curve, a sense of being carried along with the disk. Dust grains follow these paths faithfully, each orbit smoothing itself into the next. Gas flows inward, warmed by compression, while the outer regions spread into a broad, delicate circle. Planets will one day be born here, from these spiraling grains that now seem so small and insignificant. But the protostar itself is changing too. The rotation helps it collect material evenly, guiding in falling gas toward its poles or equator, shaping the growing sphere into a more stable form. Inside, pressure continues to rise. Heat builds, and all of it happens in steady time with the rotation, a cosmic lullaby humming through gas, dust, and darkness. There's something soothing about this motion. It reminds you of the way thoughts spiral before sleep. Slow, looping reflections that circle back to themselves, becoming simpler, calmer, softer with each pass. The forming star isn't rushing, it's settling, gathering, becoming. Light does not yet escape the cocoon of dust around it, but the rotation hints at the brilliance that will one day emerge. The disk glimmers faintly in infrared light, invisible to human eyes but glowing warmly in the silence. Every turn shapes the future, where planets will form, how the star will spin across its lifetime. what kind of solar system will one day arise. As you breathe in, imagine the disk expanding slightly, the motion smooth and effortless. As you breathe out, imagine the spiral settling inward, tightening gently around the protostar. In, a drift outward. Out, a quiet turn towards center. Your breath mirrors the rotation, calm and balanced. The gentle twirl of becoming is one of the universe's softest gestures, a quiet promise that something bright is preparing to take shape. Nothing is rushed, nothing is forced, just slow, patient motion, guiding a new star toward its first light. As the protostar spins inside its cocoon of dust and gas, something steady and inevitable unfolds. Material from the surrounding disk begins to fall inward, drawn by gravity in a slow, spiraling descent. This infall of matter is called accretion, and it is one of the most peaceful yet essential processes in the birth of a star. With every grain of dust that settles onto its surface, with every drifting molecule pulled into its growing body, the protostar feeds on its own future, gathering the mass it needs to ignite. Imagine hovering close to this forming system. The disk stretches out beneath you like a wide, dimly glowing river of material. It doesn't rush, it flows. Spirals of dust slip silently around the protostar, narrowing their paths gradually, drawn inward by gravity's quiet guidance. As each particle approaches the center, it speeds up just slightly, tracing smaller and smaller circles before disappearing into the warm, dense heart of the protostar. The process is gentle. To human eyes, it would seem almost motionless, too slow to notice. And yet, over thousands of years, this calm drizzle of matter adds heat to the core. Not the fierce heat of fusion, not yet, but a soft internal warmth created by compression. Each particle that joins the protostar releases a tiny bit of gravitational energy, like a sigh of warmth shared into the cold. You can imagine that warmth now as a reddish glow deep inside the forming star, spreading slowly outward. It doesn't break through the dusty cocoon around it, but it thickens the air inside, raising the temperature a little more with each passing century. The protostar's interior swells with heat and pressure. Its surface flickers in turbulent patterns, pockets of gas swirling as they meet newly arriving material. Accretion is also messy in a gentle cosmic way. Sometimes the infalling matter forms bright arcs, or creates temporary hotspots on the protostar's surface. These regions glow faintly in infrared light, like warm patches on a cooling ember. But these changes are slow and rhythmic, never violent, never abrupt. The protostar is still growing, still learning to balance itself, still collecting the strength it needs to shine. Meanwhile, the disk around it changes shape. As more material falls inward, the outer regions become thinner. Gaps may appear where planets will one day form, carved slowly by the motion of gas or the gravity of emerging bodies. But for now, the star-to-be remains the central story. A warm sphere gaining mass, preparing quietly for a future when its heart will ignite. There is a gentle lesson in this stage. Growth doesn't always look bright or dramatic. Sometimes it looks like gathering, collecting, accepting what comes. Small steps, repeated steadily, shaping something strong from within. The protostar doesn't demand light. It earns it, slowly, patiently, through the quiet intake of material that will one day become fuel for fusion. As you breathe slowly, imagine the disk circling beneath you in long spirals. Inhale as the outer dust drifts freely around the star. Exhale as the inner dust settles inward, returning to the center. Your breath becomes a mirror of the star's slow, nourishing intake. One day, the warmth inside will be enough. One day, the pressure will reach the critical threshold, and one day soon, the star will shine. For now, it simply gathers, feeding gently on its future. As the protostar continues drawing material inward, The swirling gas and dust around it begin to settle into a shape both simple and breathtaking. A broad, thin disk encircling the forming star like an ethereal halo. This is the protoplanetary disk, a place where future world quietly wait in the softness of possibility. Nothing here is solid yet. Nothing has taken its final form. And yet everything needed to build planets, moons, comets and asteroids is drifting gently in this slow, spinning expanse. Picture yourself moving above this young system now, looking down at the disk as it stretches outward in smooth, circular layers. The material is incredibly fine, grains of dust the size of smoke particles, molecules of gas drifting like mist, but together they form a shimmering plane that curves around the protostar with quiet grace. The nearer dust glows faintly in the warmth of the forming star, while the outer regions remain cool and shadowed, calm and patient. The disk is alive with motion but not rushing. Everything travels in wide, elegant orbits. A grain of dust might take years to complete a single loop, gliding smoothly along its path. Collisions are gentle, bonds form slowly, energy spreads evenly. The disk behaves like a cosmic river, flowing in circles, smoothing itself into a flat, balanced shape. This flattening happens naturally as the system rotates. Material that once drifted in all directions now aligns itself with the plane of rotation, flattening much like dough under soft pressure. What was once a thick, uneven cloud becomes a delicate, symmetric disk. And in this disk, the seeds of planets begin to gather. Dust grains bump into each other, stick together, drift apart and reunite. Over thousands of years they form clumps. Over millions they form pebbles, then rocks, then mountains drifting through the dark. Though this process is slow, it is full of quiet purpose. You could imagine each tiny particle carrying a dream of becoming something greater, a world, a moon, a ring around a future planet. All of these futures begin as small dust grains suspended in the calm of this disk. Closer to the protostar, heat warms the material, ices evaporate, silicates melt. This inner region shines faintly, lit by warmth rather than light. Farther out, where the cold remains deep, ices can survive. These distant zones will one day form giant planets, comets, and icy worlds, each sculpted by temperature, gravity, and time. The disk is a landscape of potential, a quiet, drifting geometry where countless destinies are set in motion before they ever take shape. It's peaceful to imagine all of this happening without noise, without brightness, without urgency. Just slow orbits, patient collisions, soft spirals. As you breathe in, picture the disk expanding softly around you, wide, calm, balanced. As you breathe out, imagine the dust settling into its orbits, aligning with the plane, becoming a little more harmonious with each pass. Your breath mirrors the disk's quiet order, its gentle organization, its slow gathering of form. One day, planets will emerge from this halo. One day, icy rings will shimmer around distant worlds. One day, life may even awaken on a small rock warmed by this young star. But for now, the disk simply turns, a flat halo of possibility, waiting for its future to unfold. Even before a star shines, it finds a way to express itself, not through light, not through heat, but through motion. As the protostar gathers material from the surrounding disk, something elegant and unexpected begins to happen. Streams of gas shoot outward from its poles, forming two narrow beams that stretch into space like soft glowing threads. These are bipolar jets, and though they appear dramatic in pictures, their origins are gentle, born from the star's attempt to find balance. This is starlight before starlight, a newborn star learning to breathe. Imagine floating near the protostar, watching these jets rise slowly from its poles. They aren't violent, they aren't explosive. Instead, they stream outward in long, smooth lines, shaped by magnetic fields twisting around the forming star. The jets look like faint beams of mist, illuminated by the slightest glow, extending for light years through the dark nursery. They bring order to the chaos, carving clear paths through the surrounding gas. These jets form because the protostar, still wrapped in its cocoon, is trying to regulate itself. As it pulls in material from the disk, it must also release excess energy. The swirling disk and the star's magnetic field guide some of this material away from the centre, channeling it into two opposite directions. It's a kind of cosmic exhale. The young star breathes in dust and hydrogen, forming its body, and breathes out these graceful streams, keeping everything stable and calm. You can picture the jets as soft, narrow rivers flowing from the poles of the star. They move slowly, slower than anything you could imagine here on Earth. But in the scale of space, they are purposeful and steady. They push aside gas that would otherwise collapse back onto the protostar too quickly. They help clear a path for the forming star to grow. And as they sweep through the surrounding cloud, they leave behind subtle waves, like ripples spreading across a still pond. Even though these jets do not shine with visible light, they glow faintly in infrared, shimmering like gentle lantern beams in the darkness. If you drift above them, you'd feel no wind, no pressure, only the quiet impression of direction, flow and balance. The jets mark the axis around which the young star will eventually spin, the orientation it will carry throughout its entire life. There is something deeply peaceful about this stage. A star is not yet ready to shine, but it is already learning how to exist, how to balance the inward pull of gravity with the outward flow of energy. It gathers, it releases, it breathes. In this quiet give and take, a sense of rhythm forms that echoes through the entire system. The disk rotates, the protostar warms, the jets stream outward, and the surrounding cloud gradually reshapes itself. As you inhale now, imagine the protostar drawing in material, slow, steady, patient. As you exhale, imagine those thin jets streaming outward, carrying away excess energy with the gentlest motion. Your breath becomes a reflection of the star's early equilibrium, a soft balancing act between taking in and letting go. One day when fusion begins, the real light will emerge, but for now the star practices its first breaths in the quiet dark, shaping the space around it with soft, elegant streams of motion. Deep inside the protostar, where no light escapes and no sound can travel, a quiet transformation is unfolding. Heat is rising, not yet bright enough to ignite nuclear fusion, but warm enough to reshape the heart of the forming star. This warmth is patient. It builds slowly, layer by layer, as gravity continues to draw material inward. What begins as the faintest whisper of heat becomes a steady, growing pressure. And in that pressure lies the promise of everything a star will become. If you could drift into the protostar's interior now, past the cocoon of dust, past the whirling disk, past the turbulence at its surface, you would enter a world of deep, muted glow. The temperature climbs with every kilometre you descend. A gentle gradient of warmth radiates outward, the side effect of 1,000,000 years of gathering mass. But it is still calm. The atoms are not yet fusing. They are simply being squeezed closer and closer together. Imagine hydrogen atoms, the simplest particles in the universe, drifting in this rising heat. As gravity compresses them, they begin to nudge against each other, not violently, but persistently, like pebbles settling at the bottom of a stream. With each compression, the temperature inches upward, the pressure thickens, the protostar's centre tightens, becoming more compact, more defined. This silent gathering of heat is one of the most meaningful moments in a star's life, because it marks the boundary between becoming and being. The protostar is not yet a star. It has no fusion, no radiance, no outward push of energy to counterbalance gravity. It is still in a state of inward collapse, controlled, slow, but continuous. And as long as gravity keeps pulling inward, the heat will keep rising. The energy generated by this compression is known as gravitational heating, but the name doesn't capture its softness. There are no flames, no flashes, no eruptions, just the slow, steady accumulation of warmth where once there was only cold. It is a quiet anticipation, like the warm breath before words are spoken. As you breathe in now, imagine the protostar's interior tightening just a little more, gravity encouraging every particle inward. As you exhale, imagine that warmth spreading outward, filling the forming star with a soft internal glow. Each breath mirrors the slow rise of temperature deep within this cocooned sphere. Eventually, though not yet, the temperature will reach around 10 million degrees. That is the point where hydrogen atoms will finally overcome their natural repulsion and fuse together, releasing energy in a radiant burst that marks the true birth of a star. But for now, fusion remains a future promise, a distant threshold waiting patiently. What you're feeling now, drifting beside this forming star, is the universe's version of inhale held just before exhale. The moment before ignition, before radiance, before the first true light. It's a moment of anticipation unlike any other. The protostar gathers itself quietly, building the strength it needs to transform from a warm glow into a brilliant, stable star. This waiting, this rising, this silent pressure. It is the heartbeat before the first beat, the deep breath before brilliance. The star is not ready yet, but it is closer than ever. As the protostar grows warmer and denser, it enters a phase that astronomers call the T-Tauri stage. Despite the stormy-sounding name, this stage is more restless than violent, a kind of cosmic adolescence, full of flickering energy and shifting moods. The young star is not yet stable, not yet balanced, and it pulses and swells as it searches for equilibrium. But even in its turbulence, the movement is gentle by human standards, unfolding over thousands of years like a slow rolling tide. Imagine drifting closer now, hovering above the young star's swirling surface. It doesn't shine with the clear light of a mature star. Instead, it glows in soft reds and oranges, the warmth from its interior slipping outward in uneven waves. Patches brighten for a while, then fade. Streams of gas rise and fall. Magnetic loops form delicate arches across its surface, lifting material and lowering it again in slow-motion choreography. The star's winds grow stronger in this stage. They sweep across the protoplanetary disk, stirring its surface like a gentle breeze crossing a field of tall grass. Clumps of dust shift. Wisps of gas drift upward and fall back. Nothing is thrown violently. Everything moves with the rhythm of a long exhale. These winds carry away some of the remaining dust near the star, helping to clear space for the light that will one day emerge. You might think of the T-Tauri stage as the star's attempt to understand itself. Inside, heat continues to rise. Outside, magnetic fields twist and stretch, guiding energy toward the surface. The young star does not yet know how to balance the inward pull of gravity with the outward push of heat. So it pulses, brightens, contracts, expands. It feels for the first time what it means to be alive with energy. Yet the turbulence is never chaotic. It has structure, like the rolling of distant thunderclouds, or the gentle, uneven glow of a fireplace. You could imagine the star practicing, learning the patterns that will one day define its steady shine. Each fluctuation reveals another layer of its future stability. As you breathe in, picture the young star contracting slightly, gravity drawing it inward. As you breathe out, imagine it swelling just a little, releasing heat into space. In, a quiet pull. Out, a gentle release. Even in its restlessness, the rhythm is soothing. The surrounding disk responds to these changes. Waves spread through it. Shadows shift. Warm regions expand and contract as the star's glow flickers. This dance between star and disk helps shape the future solar system, determining where planets may form, where comets will drift, and how material will distribute itself across millions of miles. What makes this stage so beautiful is the balance of uncertainty and purpose. The star is unsettled, but not lost. It is changing, but not breaking. It is learning how to exist. Every pulse, every brightening, every whisper of wind pushes it closer to the moment when fusion will begin, the moment when the star will finally find stability in light. For now, it is still searching, still shifting, still discovering its place in the cosmos. A stormy youth, yes, but a gentle one. A star still finding its calm. As the young star continues its warm, flickering growth, something subtle but transformative begins to happen around it. The winds flowing from its surface, once gentle and gradually strengthening during its tea-towery phase, start to spread outward with more consistency. These winds aren't like the winds on Earth, full of motion and sound. They are streams of charged particles drifting silently through space, expanding in all directions, and slowly they begin to clear the space around the star, sweeping the last remnants of the dense cloud that once hid it from view. Picture yourself drifting above the protoplanetary disk, watching the young star breathe out these winds. They move like pale, transparent currents, parting the dust the way a soft hand might smooth the folds of a blanket. The innermost regions of the disk grow clearer as the winds push dust outward, creating ripples that travel across millions of kilometers. Over time, the star begins to carve out a bubble around itself, a space where light might one day travel freely. This clearing process is not sudden. It takes tens of thousands of years, but its progress is steady. Particle by particle, the dust near the star thins. Clumps drift outward. Gas evaporates under the warmth. You could imagine the star tidying its surroundings, making space for its future radiance, preparing a calm environment where planets can form without interference. Some of the dust pushed away will eventually gather into rings or arcs within the disk. Some will drift so far that it dissolves back into the larger molecular cloud, and some will remain right where it is, surviving long enough to become the building blocks of worlds. But all of it feels the star's presence now, a reminder that the once hidden protostar is becoming a source of influence, shaping the destiny of everything around it. As you breathe in, imagine the disk expanding softly outward, dust drifting away from the star. As you breathe out, imagine the winds pushing gently through the remaining stray particles. In, expansion. Out, clearing. The star's environment becomes a mirror of your breath, moving from fullness to clarity, from density to openness. With each passing millennium, the star becomes more defined. The surrounding gas that once obscured its shape now thins, making the young star visible for the first time, not yet shining with full brilliance, but glowing faintly through the final wisps of its cocoon. This unveiling is quiet, slow, and deeply poetic. It is the birth of visibility. The clearing also stabilizes the disk. Without the constant push of infalling cloud material, the protoplanetary disk becomes more organized, more cooperative, more peaceful. Planetary seeds can now grow without disruption. Orbits can stabilize. The system begins preparing for the long, patient work of shaping worlds. There's a gentle metaphor in this moment, the way clarity gradually emerges when we remove the excess, when we let winds sweep away what no longer belongs. The star is not fighting the dust, it's simply breathing, and through that breath, its space becomes open. Soon fusion will begin, soon the real light will appear. But before all that brilliance, there is this quiet act of preparation, a young star sweeping its room, making space for the dawn that is coming. Deep within the heart of the young star, something extraordinary is taking shape. A threshold approached slowly, patiently, over millions of years. The temperature at the core has been rising with every breath of collapse, every drizzle of dust, every wave of inward pressure. The hydrogen atoms, squeezed closer and closer together, now move with an intensity shaped by gravity itself. And then, in a moment no one can see, no telescope can witness, and no sound can announce, the boundary is crossed. Hydrogen begins to fuse. Light is born from fire. You are drifting at the edge of this star now, watching from a place where the warmth feels steady and silent. You cannot see the reactions inside, but you can feel the shift, a calm, deep rhythm settling into the star's body. Until this moment, gravity has always won. It has pulled the star inward, compressing it more tightly, raising its heat. But with the first spark of fusion, the balance changes. For the first time, there is a counterforce, an outward push of energy rising from the core. Fusion is not an explosion. It is not violent. It is a continuous, gentle release of energy, the result of hydrogen atoms merging to become helium. Each fusion event creates a tiny burst of light, a minuscule whisper of heat. But there are so many of these events, trillions upon trillions every second, that the star becomes self-sustaining. The warmth no longer comes only from collapse, it now rises continually from within. Imagine the core as a quiet furnace, burning not with flames but with the merging of particles. This furnace glows with a brightness that will last for billions of years. The energy produced begins to rise slowly outward, passing through dense layers of gas, scattering, bouncing, diffusing, taking thousands of years to reach the surface. But when it finally does, it becomes something new, starlight. The outward pressure from fusion now balances the inward pull of gravity with remarkable precision. The star stops collapsing. Its body relaxes into equilibrium. For the first time, it is stable. For the first time, it is whole. This moment marks the true birth of a star. If you hover just above the star's surface, you might imagine the faint sense of expansion, a soft outward swelling as the new energy radiates gently into the surrounding environment. The star glows a little brighter now, its surface shifting from a warm red-orange to a clearer, more defined hue. The last remnants of dust around it scatter away, pushed gently by the increased pressure. A new sun has awakened. As you breathe in, imagine the star's core drawing in hydrogen, the fuel for this long, luminous future. As you breathe out, imagine its radiant warmth rising outward, glowing softly through space. In, the quiet intake. Out, the steady shine. Your breath mirrors the balance that now defines the star, a balance between pressure and gravity, between contraction and release. This moment is the universe's quiet declaration: a star exists, the glow that will guide future planets, warm distant worlds, and illuminate the night sky has finally begun. The star's long journey toward light is no longer preparing, it is happening, and from here, its story only grows brighter. The moment fusion begins inside the young star, everything changes, yet nothing looks rushed or dramatic. Instead, the transformation unfolds with the steady certainty of a tide coming in, gentle and inevitable. For the first time in the star's life, two powerful forces meet in perfect balance: the inward pull of gravity and the outward push of the energy created through fusion. This exquisite harmony is called hydrostatic equilibrium, and it is the quiet secret that allows stars to shine for billions of years. Imagine drifting just above the star's surface now, feeling the calm that settles over it. Before this moment, the star pulsed and contracted, struggling to find stability. But now the struggle has ended. The star has found its center. Gravity still pulls inward, but fusion pushes outward with equal strength. The result is neither collapse nor expansion, but peaceful stillness, a luminous balance. Inside the star, hydrogen atoms merge to form helium in a continuous quiet dance. Each fusion event releases a tiny bit of energy. Alone, one event would barely warm a grain of sand. But in the dense, brilliant core of a star, these tiny sparks happen trillions of times every second. The accumulated glow forms a steady, gentle pressure that supports the star from within. You might imagine this balance as two hands pressing softly against each other, not straining, not shaking, just meeting with equal strength. That meeting point is where the star finds its peace. The inward gravity holds the star together. The outward energy prevents it from shrinking further. Between the two, the star becomes stable, serene, radiant. From the outside, this stability manifests as a steady, unwavering glow. The flickering turbulence of earlier stages fades. The star's surface becomes smoother, calmer, more predictable. The winds streaming outward become gentler, more consistent. The disk around the star settles into a more organized pattern, its orbit shaped by this new, dependable light. As you breathe in, imagine the pull of gravity gathering the star inward, holding its form. As you breathe out, imagine the warmth of fusion, expanding gently outward, filling space with soft radiance. In, the gathering. Out, the glowing. Your breath mirrors the equilibrium that now defines the star's existence. This balance is astonishingly precise. If fusion produced just a little more energy, the star would swell. If gravity pulled just a little harder, the star would contract. But the universe has shaped a perfect meeting point, a stillness inside motion, a calm inside fire. That stillness is what allows the star to shine continuously, offering warmth and light to anything that drifts within its reach. Hydrostatic equilibrium will sustain the star for millions, billions, even trillions of years depending on its size. It is not a moment but a long state of being, a gentle plateau where the star lives out most of its life. During this time its shine will be steady, its warmth will be constant, its presence will become a reliable anchor for any world that forms around it. There is something deeply comforting about this idea, that even in a universe full of expansion and collapse, some moments resolve into perfect balance. A star in equilibrium is a reminder that opposites can meet, hold each other, and create harmony. Now the young star shines with confidence. Its long night of becoming has ended. Its day has begun. For millions of years, the young star has been warming, gathering, and preparing. Now, with fusion fully awakened in its core and equilibrium settling across its body, something profoundly beautiful begins to happen. Photons, tiny packets of light, rise slowly through the star's dense layers, weaving their way outward in a journey so long and patient that each one may take thousands of years to reach the surface. And when they finally break free, the universe receives something entirely new, light that has never existed before. Imagine hovering near the star's outer layers now. The surface, once turbulent and flickering, has calmed into a warm, steady glow. It's not harsh, it's not blinding. It is soft, golden, and full of promise. This glow is the first true light of the newborn star, the first time its radiance escapes the cocoon that once concealed it. The star has found its voice, and it speaks in light. Deep within, fusion continues its gentle work. Hydrogen atoms merge to form helium, releasing energy that spreads outward in a quiet cascade. Most of this energy will never be seen directly. It is absorbed, scattered, and transformed many times before it reaches the surface. But each photon carries a tiny bit of the star's heartbeat, a whisper from the core where creation occurs. The moment these photons reach open space, they travel freely, straight and unbroken across the dark. Some will wander for billions of years, some will warm newborn planets, some will be captured by drifting dust, and some, impossibly far into the future, They find their way to the eyes of creatures who look up and wonder where that distant glow began. As you breathe in, imagine the star drawing in hydrogen, fueling the delicate fire at its centre. As you breathe out, imagine those photons rising gently, drifting outward, breaking free. In, the gathering. Out, the shining. Your breath mirrors the star's quiet radiance. The space around the star begins to transform as well. The last remnants of dust that once wrapped it in shadow now scatter under the influence of its growing light. Shadows dissolve, the inner disk warms, lines of illumination trace the circular paths of orbiting dust grains. The young star, once hidden in darkness, now stands revealed, a beacon glowing softly at the centre of a forming planetary system. And this first light carries a special significance. It is a beginning, a declaration. Before this glow, the star existed only as potential, warm, forming, unseen. Now it exists in the cosmos, shining into the dark with its own distinct colour, its own temperature, its own quiet identity. Every star shines differently. Some blue and hot, some red and cool, some bright, some modest. But each one's first light is unique, a signature etched into the universe. It's humbling to think that every star we see in the night sky went through this moment. Every point of light on a clear evening represents a story that began in darkness, endured collapse, warmed into becoming, and finally released its first breath of radiance. Even our sun, the star that warms your skin and lights your days, once shone its first light in a similar silence. Drift here a little longer, letting that thought settle. This glow you're watching now has no memory, no past. It is new, pure and untravelled, light that has never existed before. There is no sound, no flash, no dramatic shift when a protostar becomes a true star. The transition is quiet, subtle, almost shy, more like the soft moment when night begins to lighten before dawn than the sudden rise of the sun itself. Yet this transition is one of the most profound in the universe. The young star crosses an invisible threshold, stepping from a life of becoming into a life of being. It is no longer collapsing, no longer searching for balance, no longer hidden in its cocoon. It has arrived. Imagine hovering just above the star now, watching its surface settle into a steady, confident glow. The flickering patches of its earlier life have smoothed out. The swirling turbulence of the T-Towery stage has calmed. The winds, though still flowing outward, have become more rhythmic, more even, like slow, long breaths released into the surrounding space. The star's identity is taking shape. Its colour stabilises. Its heat becomes reliable. Its presence becomes unmistakable. Inside, fusion burns steadily. The star consumes hydrogen with a patient rhythm that will last for millions or billions of years, depending on its mass. The core has tightened into a stable sphere of immense pressure, but the outward flow of energy from fusion matches gravity perfectly. The star is in balance. It is whole. This threshold marks the star's entrance onto what astronomers call the main sequence, the long, calm phase of stellar life, where it shines consistently, breathing energy into space with quiet certainty. Most of a star's existence occurs here. It will age slowly, barely changing, its warmth constant, its radiance sure. But that long, tranquil life begins with this small, invisible step. Imagine drifting slowly around the star, watching the disk around it respond to the newfound stability. Regions that were once unstable now settle. The star's consistent glow warms the inner rings, melting ices and revealing bright streaks of dust. Shadows shift in tranquil arcs. The disk begins preparing for the formation of planets, its movements guided by the star's calm gravity. As you breathe in, imagine the star's core tightening just slightly, the inward pull that keeps it stable. As you breathe out, imagine its outward radiance expanding gently, filling space, warming dust, sculpting the disk. In, gravity's embrace. Out, the star's steady breath. Your breathing mirrors the balance that now defines this new life. There is something quietly emotional about this moment. A star is not born all at once. It becomes itself slowly, through patience, collapse, warming, and learning how to breathe. And then, in a moment too soft for eyes or instruments to detect, it crosses the threshold. It stops preparing and simply is. The universe is filled with these invisible transitions, moments when potential becomes presence, when becoming turns into being. They happen in stars, they happen in planets, they happen in lives. And here, drifting beside this newly born star, you can feel the stillness of that threshold, the quiet pride of a light that now belongs fully to the cosmos. It shines, it endures, it is. If you look up at the night sky, it's easy to imagine stars as eternal, fixed points of light that have always been there and always will be. But every star you see once began in darkness, moving through slow, gentle stages of collapse, warming, swirling, and learning to shine. And all of it took time. Enormous, unimaginable time. Time measured not in years or centuries, but in millions upon millions of quiet, patient moments. As you drift near this newly formed star, let yourself feel the scale of its journey. From the first gathering of dust to the ignition of fusion, the process required tens of millions of years, not because the universe is slow, but because it is precise. Every step must unfold with care. Every stage must find balance. Stars are not rushed into existence. They are shaped deliberately, the way a river carves a canyon, softly, gradually, beautifully. Imagine the earlier stage again, the cold cloud of hydrogen drifting silently through space. It took millions of years for gravity to nudge that cloud into collapse. Millions more for a warm core to form. Millions more for the protostar to gather enough mass and heat to ignite. Each moment in that timeline mattered. Each stage built the next. Nothing could be skipped. The time it takes for a star to form also depends on its mass. Smaller stars form slowly, collapsing gently, taking their time to gather enough material. Larger stars form quickly, their immense gravity pulling material inward with more urgency. But even then, the process still spans hundreds of thousands or millions of years. Nothing in the cosmos is instant. There's a quiet lesson in this cosmic patience. Creation, whether of stars or lives or ideas, requires time to settle, time to grow, time to find balance. The universe doesn't rush brilliance. It allows potential to gather at its own pace, shaping itself through calm persistence. As you breathe in, imagine the long inward pull of gravity during the star's earliest days, slow, steady, unhurried. As you breathe out, imagine the outward glow that now radiates from the star's surface, warm, consistent, earned. In, the long becoming. Out, the quiet being. Your breath becomes a bridge between the star's past and present, reflecting the rhythm of its gradual creation. The light you see now, the star's first true radiance, has been in the making for longer than the Earth itself has existed. The photons leaving its surface may have spent thousands of years travelling through dense internal layers before reaching freedom, and now at last they slip into space, ready to journey across the cosmos. When you gaze at distant stars, you're seeing that same patience, light born from processes that began before humanity, before Earth's oceans, before life itself. Light that carries the slow, careful craftsmanship of time. And as you drift beside this newly formed star, let that idea settle gently. The universe does not hurry the things that matter. It allows them to unfold in the rhythm that is right for them. Stars take their time, and because they do, they shine with a steadiness that lasts for billions of years. Now that the young star has settled into equilibrium, its surface begins to express itself with a clearer, more confident glow. Every star has a colour, not painted on like pigment, but woven into the very temperature of its shining. And in this early stage of its long, steady life, the star reveals its hue. Some newborn stars glow with a warm red-orange, others with a golden white, and the hottest with a shimmering blue. This colour is not decoration, it is truth, spoken through light. Imagine drifting a little closer now, just far enough to observe the star's surface without being overwhelmed by its brightness. The glow feels steady, soft at its edges, like the light you see when you close your eyes against the sun. The temperature here determines everything. Cooler stars, smaller and gentler, shine in muted reds, like the last embers of a fading fire. Larger stars, young and powerful, glow blue-white, the colour of ice touched by lightning. Our own sun, when it first awakened, may have glowed a pale, youthful white before deepening into the warm gold we see today. The colour of a star comes from the temperature of its outermost layers, where photons finally escape into space. Hotter temperatures produce shorter wavelengths of light, the blues. Cooler temperatures produce longer wavelengths, the reds. Every star sings in a different key, its hue a quiet melody rising through the cosmos. As you hover near the star, imagining its warmth radiating outward, you can almost sense the way its hue shapes the world around it. The nearest dust in the protoplanetary disk glimmers in that light. Shadows stretch and faint colours. The disk grows warmer or cooler depending on the star's glow, and this temperature gradient will one day help determine where planets form. Hot, rocky worlds near the centre, icy giants in the farthest reaches. The star does not choose its colour. It emerges from its mass, its temperature, its age, from the quiet physics that guide its birth. And yet there is something poetic about this natural expression. The star's hue is a kind of cosmic personality, a signature written in light. As you breathe in, imagine the heat of the star's surface rising, its light shifting subtly from red to orange, from orange to white, from white to blue as temperature increases. As you breathe out, imagine that same light drifting calmly across the disk, illuminating dust grains that twirl in slow, perfect orbits. In, the warmth, out, the glow. Your breath mirrors the gentle radiance that now fills this newborn system. Scattered throughout the universe, young stars glow in all these hues, from deep crimson dwarfs to brilliant blue giants. Their colours paint the nebulae around them, carving soft gradients across the gas, creating the pastel portraits captured by telescopes. A star-forming region is a quiet rainbow of temperature, each star adding its own whisper of colour. And here, beside this single newborn sun, you're witnessing that moment when radiance takes form, when the star's temperature finds its voice, when the first steady colour settles over its surface, carried outward in a long, calm breath of light. This hue, whatever it may be, marks the star's early identity. Not loud, not final, but true. A newborn sun glowing in the quiet dark, painting its surroundings with the first strokes of its cosmic palette. As the newborn star settles into its long, steady glow, a quiet truth begins to shape its entire future, a truth written not in its colour, not in its brightness, but in its mass. A star's mass is its destiny. It determines how hot it will burn, how long it will live, how it will shine, and how it will eventually die. Two stars born in the same cloud, formed from the same drifting dust, can lead lives that differ as dramatically as a candle and a bonfire. Mass is the author, and it writes every chapter with quiet, unyielding precision. Imagine drifting near the star now, sensing its presence not just through light but through gravity. The star's mass is what pulls the disk into motion, what shapes the arcs of future planets, what orchestrates the entire environment around it. A small star with only a fraction of our Sun's mass glows gently, burning its hydrogen slowly, savouring its life across trillions of years. A massive star, many times larger than the Sun, burns fiercely and brightly, using its fuel with passionate intensity in just a few million years. The difference comes from the delicate physics inside the core. More mass means stronger gravity. Stronger gravity means higher pressure. Higher pressure means hotter temperatures, and hotter temperatures mean faster fusion. The star must burn brighter to support its own weight. It's not a choice, it's balance, written by the quiet mathematics of the universe. As you breathe in, imagine the star gathering itself tighter under gravity's pull. As you breathe out, imagine fusion pushing outward with matching strength. In, the weight of mass. Out, the light of energy. Your breath mirrors the dance of forces that determines how this star will live. If you're drifting beside a small star, a red dwarf, its surface might glow with a dim, steady red. Its light is soft, its pressure gentle, its lifetime unimaginably long. These stars are the survivors of the universe, outliving galaxies, perhaps outliving everything. If you're beside a giant star, hot, blue, immense, its surface blazes with intensity, its life burning fast and brilliantly, destined to end in a spectacular collapse that will seed space with heavy elements. The star before you has already had its fate determined by the amount of material it gathered during its long formation. Whether it will shine for billions of years or only millions was decided quietly during its earliest collapse, shaped by the flow of dust and gas in its cradle. Mass is not only a measure of weight, it is a measure of time. This idea echoes softly across the cosmos. Some lives burn steady, some burn bright. All burn according to the fuel they hold. And yet, no matter the mass, no matter the destiny, every star shares the same beginning, the same collapse, the same warming, the same moment of ignition. They diverge only after shining their first light. As you drift alongside this young star, let the simplicity of that truth settle. Its mass has written the rest of its story, its future brightness, its lifespan, even the elements it will return to the cosmos, all shaped by the weight it carries. Size writes the story, and the star now glows with the quiet certainty of knowing exactly what kind of life it will lead. If you drift far into the galaxy, into regions where dust clouds whisper and faint red glimmers flicker like fireflies in deep fog, you will find the most common stars in the universe, the red dwarfs. They are small, gentle, and dim to our eyes, but they are also the most patient. These are the quietest fires in the cosmos, burning not with intensity, but with endurance. And though they are modest compared to their larger, brighter siblings, their stories are among the longest ever told. Imagine floating beside one now. It glows with a soft, warm red, not bright enough to dazzle, but steady enough to soothe. The surface is cool by stellar standards, far cooler than our Sun. Fusion inside proceeds slowly, carefully, releasing energy at a measured pace. This unhurried burn allows red dwarfs to stretch their lifetimes far beyond those of larger stars. While our Sun will shine for about 10 billion years, a red dwarf might continue glowing for trillions. It is a star that takes its time, not because it must, but because it can. Small mass is the reason for this longevity. The gravity within a red dwarf is gentle. The pressure in its core is moderate. Hydrogen does not fuse rapidly. Instead, the star sips its fuel, using only what it needs. And unlike larger stars, which leave behind unburned hydrogen in their outer layers, red dwarfs mix thoroughly, stirring their interiors like a slowly turning spoon. This mixing ensures that nearly all their hydrogen becomes available for fusion, allowing them to use their fuel with remarkable efficiency. As you breathe in, picture the deep, steady warmth building at the core. As you breathe out, imagine that warmth drifting outward in a slow, constant glow. In, the quiet burn. Out, the endless shine. Your breath mirrors the star's long, unbroken rhythm. The surface of a red dwarf is calm, but not entirely without life. Gentle swells of convection rise and fall. Distant flares ripple occasionally, not explosive, but more like the flickers of an ember when a soft breeze passes. These flares add subtle texture to the star's glow, momentary brightening that fades into the familiar red warmth. Drifting beside this small star, you might feel a profound sense of steadiness. Nothing about it feels hurried or unstable. There is no sense of urgency, no fear of running out of fuel, no pressure to burn brightly. It exists with patience, with quiet confidence in its longevity. In the timeline of the galaxy, these stars are almost eternal. Around many red dwarfs, worlds orbit closely, warmed by the star's gentle light. Some may be rocky, some icy, some with oceans hidden beneath frozen crusts. Their daylight would be muted, cast in soft crimson tones. Shadows would be long and delicate. Nights would stretch warm and dim, lit by a star that rarely changes. There's a comforting metaphor here. Brilliance is not the only form of strength. Endurance matters too. Quiet warmth can outlive blazing fire. Small stars with their gentle glow will be the last lights in the universe long after large stars fade. As you drift a little farther from the red dwarf, let its gentle persistence settle into you. The quietest fires can burn the longest, and in the deep future when galaxies grow dim, it will be stars like these that still shine. Tiny beacons in an ancient, cooling cosmos. In every stellar nursery, alongside the gentle red dwarfs and the steady sun-like stars, a few rare giants are born, enormous, brilliant, and destined for short, spectacular lives. These massive stars blaze with such intensity that they illuminate entire nebulae, shaping their surroundings with powerful winds and fierce radiation. They are the bright, brief flames of the cosmos, dazzling, transformative, and fleeting. Imagine drifting toward one now. Even from a great distance, the star's light feels different, sharper, bluer, almost electric. Massive stars shine with a brightness tens, hundreds, or even thousands of times greater than the sun. Their surfaces burn at temperatures so high that their glow shifts toward the blue-white end of the spectrum, creating an icy radiance that belies the heat beneath. This intense brilliance is a direct consequence of their enormous mass. Gravity pulls these stars inward with tremendous force, compressing their cores to incredible densities. Fusion races to keep up burning hydrogen at a rapid, almost frantic pace to counterbalance the gravitational squeeze. Where smaller stars sip their fuel, massive stars devour it. The result is a life lived in fast forward, beautiful, powerful, but dramatically short. As you hover near this giant, imagine the core burning millions of times hotter than the surface, hydrogen fusing with unmatched ferocity. The outward pressure from this fusion creates winds so strong they carve paths through nearby gas, shaping entire regions of space. These stellar winds are not gentle like those of younger, smaller stars. They are powerful currents that push dust aside, sculpting the nebula into pillars, ridges, and glowing arcs. If red dwarfs are whispered embers, massive stars are cosmic blowtorches. And yet, even here, there is grace. On the surface of this blazing star, shimmering ripples of plasma dance in slow waves. Magnetic fields twist like luminous ribbons. The light, though intense, spreads smoothly across the surrounding gas, painting it in brilliant blues and purples. Nebulae surrounding these massive stars glow with a surreal beauty, illuminated by radiation so strong that they become cosmic lanterns. As you breathe in, imagine the inward force of gravity, immense and relentless. As you breathe out, imagine the powerful outward push of fusion, bright and unstoppable. In, compression. Out, radiance. Your breath mirrors the star's overwhelming energy, the balance it somehow maintains despite its incredible mass. But this balance is temporary. Massive stars live fast and die young. Some burn for only a few million years. The blink of an eye compared to the lifespans of smaller stars. Their fates, however, are spectacular. When their fuel runs low, they cannot sustain the immense pressure needed to support their cores. Collapse becomes catastrophic. The star implodes, then explodes outward in a supernova, scattering heavy elements, iron, gold, calcium, into space. Those elements will drift through the galaxy, becoming part of new clouds, new stars, new planets, and eventually, new life. As you drift around this brilliant star, you may feel a quiet awe. Its brightness is overwhelming, but its purpose is clear. It lives not in longevity, but in contribution. It enriches the universe with the materials needed for complexity, for worlds, for life itself. The bright, brief flames burn quickly, but they leave behind the seeds of everything. If you drift far enough from the blazing giants and the gentle red dwarfs, you'll notice something beautiful about starbirth. It almost never happens alone. Stars are social in their beginnings. They emerge in groups, dozens, hundreds, sometimes thousands, bound at first by the same cloud, the same collapse, the same quiet cradle of dust. These groups are called star clusters, and they are the cosmic families of the universe, born together before time slowly spreads them apart. Imagine hovering over one now. In every direction, young stars glow softly, their light weaving through the mist like lanterns suspended in fog. Some are faint red embers, others shine strong and white, a few burn blue and brilliant. All of them, despite their differences, emerge from the same swirling cloud that once drifted here in peaceful darkness. From above, the cluster looks like a scattering of fireflies drifting lazily in a quiet field. Each star pulses gently, its light steady and patient. The dark spaces between them are filled with dust, now thinning as the newborn suns sweep it aside. You sense the shared history among them, the way siblings might share an unspoken past. Each star shaped by the same environment, the same collapse, the same early tug of gravity. Clusters form because the giant molecular clouds that give birth to stars are enormous and irregular. They don't collapse all at once, but in pieces, folds, knots, pockets. Each pocket becomes a star, and many pockets form together, creating a small neighborhood of newborn light. These stars will drift together for millions of years, orbiting their shared center of mass, gently influencing each other through gravity's soft pull. As you breathe in, imagine the cluster tightening slightly, its members held close by mutual gravity. As you breathe out, imagine them drifting outward, beginning their long migration through the galaxy, in, together, out, apart. Your breath mirrors the slow, graceful dance that star clusters perform for ages. Some clusters will stay bound forever, becoming ancient globular clusters filled with old, faint suns. Others, especially the open clusters like the one you're floating through now, will gradually disperse. Over time, stars drift apart, tugged by the gravitational tides of the galaxy. They find new paths, new neighborhoods, new orbits. They may travel light years from their birthplace before their lives end. Even our own sun was once part of such a cluster. It was born alongside hundreds of sibling stars, all glowing softly in the same nebula more than 4 billion years ago. But as the cluster dispersed, those siblings drifted across the Milky Way, scattered over incredible distances. Even now, astronomers are searching the skies for them. Stars that share the same chemical makeup, the same origin story, the same first cradle of dust as the Sun. Floating here in this cluster, you might feel a quiet warmth at the idea. Every star you see was once part of a shared beginning, a shared breath, a shared cloud, a shared moment before drifting into its own path. The universe rarely creates in isolation. It creates in families, in groups, in shimmering gatherings of light. Here, surrounded by these newborn stars, you witness that early togetherness, the gentle glow of siblings before distance and time gently separate their paths. Among all the stellar nurseries in the sky, few are as iconic or as breathtaking as the one nestled in the sword of the constellation Orion. The Orion Nebula has been a cradle of stars for millions of years, glowing softly in the night like a lantern hung beneath Orion's belt. Even with the naked eye from dark skies, you can see a faint smudge of light. But through a telescope, or through your imagination now, it becomes a vast swirling cathedral of colour and motion, filled with newborn stars emerging from veils of gas. Imagine drifting into this nebula. The space around you glows with shades of violet, rose, and soft blue. The gas is not solid or thick, but luminous and airy, like watercolour paint suspended in space. Dust lanes curve through the nebula like dark rivers. Behind them, distant stars shimmer like tiny sparks caught in mist. This region is one of the most photographed in the universe because it feels alive, a place where creation is still underway, where light is being born in real time. At the heart of the Orion Nebula lies a tight cluster of 4 bright stars known as the trapezium. These stars, young and powerful, shine like lanterns, illuminating the gas around them and carving cavities within the nebula. Their light scatters through the dust, creating soft gradients that ripple through the clouds. If you hover near them, the glow feels warm and nurturing, the way a nightlight warms a quiet room. All around the trapezium, young stars continue to form, hidden in dense knots of gas. These protostars glow softly in infrared light, invisible to human eyes but radiant to telescopes that can see deeper into the dust. Some of them still wear their cocoon-like shrouds. Others have begun to emerge, sweeping away their coverings through stellar winds. The entire region feels like a nursery full of newborns, each at a different moment of awakening. As you breathe in, imagine the nebula expanding slightly around you, gas drifting in gentle waves. As you breathe out, imagine bright pockets of light pooling in the darkness, revealing the outlines of forming stars. In, the glow of creation. Out, the breath of the nebula. Your breath merges with the slow, luminous flow of this cosmic cloud. The beauty of the Orion Nebula is not just in its colour or brightness, it's in its scale. This one region spans dozens of light years, filled with thousands of young stars at various stages of life. Some will grow into red dwarfs, some will become suns like ours. A few may evolve into massive stars, illuminating their surroundings with breathtaking brilliance. And hidden throughout the nebula are protoplanetary disks, small dusty halos where future planets are already forming. For humanity, the Orion Nebula holds a special place. Ancient sky watchers saw it without knowing what it was. Early astronomers sketched it with awe. Modern telescopes reveal structures beyond imagination, glowing cavities, swirling pillars, and radiant shockwaves. It is, in every sense, a portrait of the universe creating. As you drift through this celestial lantern, let the colours and light settle into you. This is not just a place of stars, but a place of beginnings, a reminder that beauty, complexity, and life often emerge from clouds that appear dark from afar. Here in Orion's soft lanterns, the universe is still painting. If you travel deeper into a stellar nursery, beyond the bright gatherings of newborn stars and the luminous swirls of gas, You will sometimes find towering structures rising from the darkness, enormous columns of dust and molecular hydrogen shaped by light itself. These are the pillars of star-forming regions, the most famous of which are the pillars of creation in the Eagle Nebula. They look like mountains suspended in space, sculpted not by wind or water, but by starlight, by the very radiation of the stars they helped create. Imagine drifting toward one of these pillars now. From afar it looks solid, almost stone-like, but as you approach, you realize it is made of gas and dust so diffuse that you could pass through it without ever feeling resistance. The structure glows faintly in scattered light, backlit by the young, hot stars that lie just beyond it. Shadows stretch across its surface, forming soft, textured gradients that ripple like smoke frozen in time. These pillars exist because newborn massive stars bathe their surroundings in intense ultraviolet radiation. This radiation pushes on the surrounding gas, shaping it the way sunlight shapes clouds at the edge of a storm. Dense regions resist this push, shielding the material behind them. Over thousands of years, the dense regions remain intact, while the lighter gas around them is carved away. What remains are tall silhouettes, cosmic sculptures created by the star's own brilliance. Inside these shadowed columns are pockets of even denser gas, hidden from the harsh radiation. These pockets act as cradles for new protostars, protecting them until they grow massive enough to ignite. From a distance, the pillars may look like dark, looming figures, but they are actually nurseries, places where the next generation of stars sleeps, waiting for the right moment to awaken. As you breathe in, imagine drifting deeper into the cool shadow of a pillar, where dust softens the starlight into a gentle glow. As you breathe out, imagine the outer layers evaporating slowly under the warmth of nearby massive stars. In, shelter. Out, shaping. Your breath echoes the slow sculpting that forms these majestic silhouettes. The edges of the pillars glow softly, where radiation strikes the surface head-on. You can picture this as a thin line of light, a rim where dust gently disintegrates into glowing gas. These boundary layers are places of change, where the cold interior meets the warm touch of starlight. The contrast creates an almost painterly edge, as if the universe itself were tracing the outline of its structures with a luminous brush. These vast forms remind us that star formation is not just a process, it is an art. Light and gravity work together, carving, shaping, protecting, and revealing. The pillars are temporary sculptures, lasting only a few 100,000 years before they evaporate completely. But in that time, they hold within them the seeds of countless new stars. As you drift away from the pillars, look back at their towering shapes. They stand like monuments to creation, shadows holding light within, guardians of beginnings. Their grandeur is quiet but profound. In these sculpted shadows, the universe writes its next chapter, patiently, beautifully, in the soft interplay of dust, light, and time. As stars awaken within a nebula, their light doesn't simply illuminate the space around them, it reshapes it. Radiation streams outward, pushing on dust grains, warming gas, sculpting entire landscapes of light and shadow. The young stars, still new to their brilliance, begin to carve out pockets, bubbles, and arcs in the cloud that once cradled them. It is one of the quietest forms of influence in the cosmos, light making room for itself. Imagine drifting near a newborn star as its glow spreads into the surrounding gas. The light isn't harsh, it doesn't tear or shred. Instead, it nudges the dust gently, like a soft breeze through morning fog. This push is called radiation pressure, a subtle force created by photons leaving the star. Each photon is tiny, but when billions upon billions of them stream outward every second, they create a slow but persistent movement in the cloud around the star. The effect is delicate, The gas closest to the star warms, causing it to expand slightly. Dust grains begin to drift outward, clearing a small hollow around the star. Over time, these hollows grow into vast bubbles, cavities carved not by violent winds, but by steady illumination. These structures, shaped over hundreds of thousands of years, become the star's first home, a bright chamber within a sprawling nebula. As you hover just inside one of these glowing cavities, you can see the walls shimmer. Light from the star scatters through the dust like sunlight through mist in a quiet forest. Colours shift from warm golds to cool blues, blending into soft gradients. The edges of the bubble appear almost translucent, as if painted with watercolour. This is the nebula learning to breathe in the presence of newborn light. The interaction between radiation and dust doesn't stop at clearing space. It also shapes the remaining material. Dense regions of the cloud resist the push of light, casting long shadows that trail behind them. These shadowed zones become cool shelters where new protostars can form. In this way, light becomes both sculptor and protector. It clears pathways but also creates safe pockets where future stars can grow in darkness. As you breathe in, imagine the surrounding gas expanding gently, warmed by the star's glow. As you breathe out, imagine dust grains drifting outward, settling into new patterns. In, expansion. Out, carving. Your breath mirrors the slow shaping of the nebula, the way light steadily rearranges its birthplace. Over time, these carved regions reveal their own beauty. Some form arcs that glow in brilliant colours. Others create ridges where dust gathers, illuminated by passing starlight. Some become vast open spaces, nursery rooms where young stars shine unobstructed, lighting the nebula from within like lanterns in a great cathedral. Light is gentle here, but its influence is lasting. Without a word, without a sound, it rearranges the entire cloud. It chooses what becomes illuminated and what remains hidden. It gives shape to chaos, turning an amorphous cloud into a landscape full of delicate contours and shifting colours. As you drift away from one of these carved cavities, look back at the scene behind you. The nebula glows more softly now, its shapes more defined. You can trace the pathways where light has travelled, see the shadows it has cast, and feel the steady patience with which it builds its home. In this quiet interplay of illumination and dust, the universe demonstrates that even the gentlest forces can shape the larger structures. As the newborn star settles into its steady glow, the disk around it becomes a place of quiet change, a slow, drifting sea of dust and gas where the smallest grains begin to gather into something more. These grains, once nothing more than specks floating in the nebula, now find themselves drawn together by gentle collisions, sticky interactions, and the subtle pull of gravity. Slowly, patiently, they begin to grow. This is the moment where worlds begin as whispers, planets waiting for their chance. Imagine drifting just above the protoplanetary disk now. The surface stretches beneath you like a wide, dimly glowing ring. Warm light from the star reflects off its inner regions, creating a hazy radiance that fades gradually into the cool, shadowed outer layers. The material here is soft, almost fluid in its motion. Tiny grains of rock and ice drift in slow spirals, brushing against one another with the faintest touch. Each collision is gentle, almost imperceptible, but it matters. Dust grains stick together. Tiny clumps become pebbles. Pebbles become boulders. Boulders gather into mountain-sized bodies called planetesimals. These growing forms carve small tracks through the disk, much like boats gliding through a calm lake. Over millions of years, gravity takes hold more strongly, pulling material inward, shaping each planetesimal into something larger, more complete. The inner disk is warm, sculpted by the star's steady heat. Here, the building blocks of rocky planets gather, future worlds with solid surfaces and metallic cores. In the outer disk, where the cold is deep and quiet, ices accumulate, forming the seeds of gas giants and icy moons. Each region has its own rhythm, its own destiny, guided by temperature, radiation, and the slow dance of motion around the star. As you breathe in, imagine dust grains drifting freely, suspended in the warm glow. As you breathe out, imagine them settling, joining, becoming something just a little larger. In, possibility. Out, formation. Your breath mirrors the slow, quiet gathering that turns dust into planets. Some regions of the disk begin to show faint gaps, delicate rings where material has been cleared away by newly forming bodies. These gaps hint at futures still hidden in dust, the orbit of a planet to be, tracing its path around the star. The disk becomes a tapestry of bands and lanes, sculpted by these invisible architects drifting silently below you. Occasionally a larger body stirs the disk, sending soft waves through the surrounding material, like ripples spreading across a still pond. These ripples encourage more dust to collect, more collisions to happen, more growth to unfold. Everything influences everything else. The birth of a single planet changes the shape of the entire system, guiding the fates of countless smaller bodies. In this disk, silence is deceptive. Though nothing looks rushed, every moment is full of creation. Worlds are forming right now, small, fragile, incomplete, but alive with possibility. Some will become planets warmed by the star's embrace. Some will become moons orbiting those planets. Some will become comets drifting in long icy arcs across the system. And some, perhaps many, will never form fully, remaining forever as drifting dust, reminders of the paths not taken. As you drift above this quiet cosmic sea, let the vastness of these possibilities settle into you. Every planet begins as a cloud grain, every world begins as a whisper, and here, in the gentle glow of a newborn star, countless futures are gathering themselves, waiting for their chance. Drifting through the protoplanetary disk, you begin to notice a quiet transformation unfolding all around you. Not in the stars, not in the dust, but in the simple molecules that drift between them. Water in all its forms becomes one of the key architects of young planetary systems. Here in this early, fragile environment, you find steam, ice and vapour swirling through the disk like soft breath in cold air. And within these forms of water lies a story of temperature, distance, and destiny. Imagine lowering yourself gently into the inner regions of the disk. The warmth here is unmistakable, a gentle heat radiating from the newborn star, warm enough to keep water in the form of vapour. Steam drifts through the gas like faint invisible threads. It coats dust grains with a thin film, making them stickier, helping them form clumps that will later grow into the seeds of rocky worlds. The air here, if it could be called air, is rich with water molecules moving in slow, graceful arcs. This region, close to the star, is where the future inner planets will form. Their building blocks float through this warm fog now, colliding into pebbles, pebbles into stones, stones into worlds. Water vapour becomes a quiet catalyst for growth, helping matter cling and combine in ways it couldn't otherwise. But drift a little farther out, and everything changes. The warmth fades, light softens, a gentle cold settles in. Not harsh, not biting, but deep and steady. Here, water begins to freeze. Dust grains become coated with icy mantles, glimmering faintly in the starlight. These icy particles stick together even more easily than their rocky cousins. They form clumps rapidly, gathering mass with quiet enthusiasm. This region, just beyond what astronomers call the snow line, is where giant planets are born, the cold, swirling worlds of hydrogen, helium, and thick oceans of vapour. As you breathe in, imagine the warm vapour drifting in the inner disk, light and fluid. carrying the seeds of rocky planets. As you breathe out, imagine the icy grains farther out, gathering in silence, building the cores of giant worlds. In, steam, out, ice. Your breath becomes the boundary that divides these regions, a natural partition written by temperature and distance. Even farther still, where the disk grows thin and dim, water becomes the architect of comets, small, icy wanderers that will one day carry frozen reservoirs of water into the inner system. These comets are time capsules, storing ancient ices unchanged for billions of years. In the early days of a planetary system, they often drift inward, delivering water to newborn rocky worlds. Some scientists believe that Earth's oceans were seeded this way, by icy messengers born in the cold outskirts of a disk just like this one. As you glide through the outer layers, you see these comet seeds drifting alone, small and silent, clumps of ice and dust trailing delicate tails behind them. They move slowly, as if waiting for their moment to cross paths with a forming world. Water, in all its forms, is everywhere. It shapes the fates of planets. It determines where life might someday emerge. It sculpts ice giants, feeds comet clouds, and gives rocky worlds their oceans. It is a quiet, essential presence in the story of starbirth. Steam, ice, and stardust. 3 forms, 1 molecule, shaping entire solar systems with gentle, patient hands. As you drift through the young stellar system, you begin to notice patterns, delicate arcs in the dust, spirals in the gas, jets aligned with perfect symmetry. These shapes are not random. They're guided by something silent, something unseen. Magnetic fields weave through the forming star and its disk like invisible threads, organizing motion, shaping structure, and guiding the paths of light and matter. Though you cannot see these fields directly, you can feel their presence in the harmony of everything around you. Imagine hovering just above the star, watching thin streams of plasma rise and fall across its surface. These streams twist, ripple, and shimmer, following magnetic lines that loop outward and back again in graceful arcs. These arcs are like the loops of a harp string, vibrating gently as energy flows through them. The star's rotation winds these magnetic threads tighter, strengthening their influence and shaping the behavior of everything nearby. Magnetic fields also thread through the surrounding disk. Dust grains, especially those containing iron or other metals, align themselves along these invisible lines, orienting their motions like tiny compass needles. Gas flows along magnetic pathways, creating spirals that lace through the disk like soft ripples. Even the bipolar jets that the star launched earlier owe their shape to magnetic fields, which guide the escaping material into narrow, elegant beams. As you breathe in, imagine these invisible lines gathering softly, drawing material into quiet curves. As you breathe out, imagine energy flowing along them, releasing pressure, restoring balance. In, structure. Out, flow. Your breath mirrors the gentle crafting that magnetic fields perform across the forming system. These magnetic threads play a vital role in slowing the star's rotation. Without them, the star would spin much faster, perhaps too fast. As the star contracts, it naturally spins quicker, just like a dancer turning faster when pulling their arms in. But magnetic fields connect the star to the disk, transferring angular momentum outward. This connection acts like a brake, allowing the star to slow its spin and stabilize its future evolution. Magnetic fields also help regulate accretion, the flow of material from the disk onto the star. Gas does not fall straight inward. Instead, it follows the magnetic pathways, channeling toward the star's poles. This organized flow reduces chaos, ensuring that accretion remains steady and gentle. Where the gas meets the star's surface, Bright spots flicker briefly before blending into the quiet glow. Even on larger scales within the nebula, magnetic fields shape the birth of stars. They thread through entire clouds, resisting collapse in some regions while guiding it in others. Filaments in giant molecular clouds often align with magnetic direction, forming vast, delicate structures that span light years. Gravity pulls matter inward, but magnetism tells it how to move. You may not see these fields, but their fingerprints are everywhere. In the swirling of dust, the direction of jets, the shape of the disk, the pulse of the star. They add harmony to what would otherwise be chaos, creating a quiet order in the vastness of space. As you drift through the disk one more time, look at how the dust curves, how the gas flows, how everything seems to follow an elegant, invisible pattern. This is the artistry of magnetic fields, subtle, patient, guiding the formation of stars and worlds through threads no eye can see. Even in the calmest corners of a forming star system, the gas and dust are never truly still. They drift, swirl, collide, compress, expand, and fold into themselves with slow, quiet purpose. This movement is not chaotic in the way storms on Earth are chaotic, loud, forceful, unpredictable. Instead, what astronomers call turbulence in a molecular cloud is more like the soft motion of underwater currents. It is motion with gentleness, movement wrapped in silence, a stillness inside motion. Imagine drifting through a cool, shadowed region of the disk now. You feel no wind, no push, no sound. And yet the grains of dust around you drift slightly up, slightly down, tracing tiny spirals as if floating in a dream. Wisps of gas stretch like faint silk ribbons, curling around each other before loosening again. This is turbulence, not a frenzy, but a quiet dance of motion too subtle for the eye to catch, unless you linger long enough to feel it. Turbulence is essential. Without it, the disk would settle into too perfect a structure, leaving matter evenly spread and preventing the small clumps from forming that eventually grow into planets. These gentle eddies bring particles together. They mix warm and cool regions. They create pockets where density can increase. They stir the ingredients of worlds the way a soft hand stirs water in a bowl. Not violently, but enough to keep the mixture dynamic. As you breathe in, imagine gas swirling inward in long, graceful lines. As you breathe out, imagine the eddies relaxing outward, releasing tension. In, the drift. Out, the ease. Your breath matches the rhythm of this subtle cosmic stir. If you watch carefully, you'll see turbulence in everything around you. Dust grains don't move in straight lines. Their paths wiggle softly, nudged by collisions too tiny to notice individually. Slight temperature differences cause pockets of gas to rise or fall. The magnetic fields from the star create small currents that twist through the disk. All of these influences layer together, creating a complex but peaceful flow. This motion also helps transport heat, carrying warmth outward from the inner disk and guiding cooler materials inward. These exchanges shape where different kinds of planets will form. Rocky worlds need warmth. Icy giants need cold. Turbulence keeps these regions connected, ensuring that no part of the disk becomes isolated or stagnant. Even the molecular cloud that collapsed to form the star experienced turbulence, vast slow waves of motion spanning light years. These motions brought together the dense pockets that allowed the original collapse to begin. Without that gentle disorder, the cloud might have drifted for eons without ever giving birth to light. There's a quiet metaphor here. Growth rarely comes from stillness alone. It often comes from subtle motion, from gentle disruptions that encourage change, from soft currents that keep possibilities mixing. Too much chaos scatters, too much stillness stalls, but the right balance, the quiet turbulence of becoming, invites creation. As you drift through this softly shifting disk, feel how each tiny motion adds to the whole, how every swirl, every eddy, every drifting grain contributes to the future shape of the system. New worlds are being sculpted not only by gravity and heat, but by these peaceful, persistent motions. Turbulence is not noise. It is not confusion. It is the universe stirring itself gently, preparing the space where stars and planets will grow. In the vast expanse of a stellar nursery, stars do not simply emerge in isolation. They influence one another through light, heat, radiation, and pressure. And sometimes the birth of one star becomes the spark that ignites the birth of another. This quiet chain reaction, where one star's presence helps create new stars nearby, is one of the most elegant patterns in the cosmos. It is a reminder that creation often inspires creation. Imagine drifting through a nebula where a group of young, massive stars has just formed. Their light is bright enough to carve windows into the surrounding cloud, illuminating pockets of dust that once lay hidden. The ultraviolet radiation they emit gently heats the nearby gas, causing it to expand and push outward. This expansion creates pressure waves, soft advancing fronts of energy that travel through the cloud like ripples across a pond. These pressure waves compress the gas they move through, and compression is the first ingredient in the recipe for star formation. Where the waves pass, the cloud grows denser. Tiny pockets that were once too diffuse to collapse now gather enough mass to begin contracting under their own gravity. Within these newly thickened regions, protostars begin to form, small seeds of light inspired by the presence of their brighter siblings. As you breathe in, imagine the nebula drawing together in these pockets of density. As you breathe out, imagine the pressure waves sweeping outward, guiding the cloud into new shapes. In, gathering, out, prompting. Your breath becomes a quiet echo of this cosmic interplay. This phenomenon is known as triggered star formation. It is not forceful. The radiation doesn't shove or tear the cloud apart. Instead, it gently nudges certain regions into the right conditions for collapse. Massive stars, with their intense light and powerful winds, become catalysts. They help shepherd the next generation of stars into being, clearing some areas while compressing others. You might picture the process as a series of lanterns being lit one by one. The first lantern glows brightly, its light spreading outward. Wherever that light touches the fog around it, the fog thickens in some places and thins in others. In the thickened pockets, new lanterns begin to glow. Over time, the nebula becomes dotted with these newborn lights, each one influenced by the radiance of the ones that came before. This pattern appears throughout the universe. In regions like the Carina Nebula, the Rosette Nebula, and the Eagle Nebula, massive stars sit at the centres of cavities they've carved, while younger stars ring the edges, born in the compressed, sculpted gas. The first stars become architects for the next, shaping the nebula's future through their presence alone. As you drift through one of these regions, perhaps along the illuminated rim of a star-carved bubble, you see clusters of protostars nestled in the newly dense folds of the cloud. Their faint glow flickers through the dust like candlelight filtered through thin curtains. These young stars owe their existence in part to the energy of their massive neighbours. This quiet chain reaction is one of the universe's most beautiful rhythms. One star forms, its light reshapes the cloud. New stars gather, light spreads, creation ripples outward, not aggressively, but gently, purposefully, with the slow patience of cosmic time. One star creates another, and the nebula continues to bloom. Not all star births are sparked by gentle nudges of light. Sometimes, the beginning of a new star's life is triggered by the end of another's. When a massive star reaches the end of its brilliant brief existence, it collapses inward and then explodes outward in a supernova, an event so powerful that it sends shockwaves rushing through space. These shockwaves travel for light years, pressing into nearby clouds, stirring their stillness, and whispering a quiet invitation for new stars to form. Imagine drifting at the edge of a vast molecular cloud, where the gas is cold, dense, and silent. Suddenly, though not suddenly in human time, a distant star ends its life in a soft flash of light that grows into a wave of energy. You do not hear it. Space carries no sound. But you see the thin shell of material expanding, glowing faintly, drifting outward with slow, unstoppable grace. This shell is a shockwave, not destructive chaos, but a sculpting force. As the shockwave reaches the cloud, it compresses the gas just enough to awaken gravity's long-dormant influence. The cloud, once too diffuse to collapse, now finds itself squeezed along the shockwave's advancing front. Dense regions emerge like ripples forming on a lake after a pebble falls in. These ripples are seeds, pockets where the pressure has become high enough to trigger gravitational collapse. In these pockets, new stars quietly begin. As you breathe in, imagine the cloud gathering under the gentle push of the shockwave. As you breathe out, imagine the wave drifting onward, leaving behind stirred pockets of density. In, compression, out, release. Your breath echoes the rhythm of collapse and quiet that guides this process. Shockwaves don't tear the cloud apart. They caress it with steady pressure. The wave moves slowly, far more slowly than you might imagine, travelling through space at speeds measured over thousands of years. It is patient, persistent, gentle enough not to destroy the cloud, but strong enough to encourage it to rearrange itself. This kind of star formation is known as triggered collapse. It happens in many regions of space, especially around the remnants of supernovae. The shockwave acts like a soft hand pressing clay, shaping the edges of the cloud, encouraging folds and ridges that become the birthplaces of stars. The famous nebula W44, for instance, shows long arcs where shockwaves from ancient supernova pressed against gas, creating new star-forming regions along the edges. In some places, the shockwave ignites a chain reaction. One pocket collapses, forming a star. That star later shines brightly, carving and reshaping the surrounding gas. Its radiation creates new dense knots, each a potential cradle for more stars. The cycle continues. Death becomes birth. Endings soften into beginnings. As you glide along the illuminated edge of a shockwave-carved cloud, you see small protostars glowing faintly in their dusty cocoons. They are young, fragile, and just beginning their journey toward light. Their existence was sparked by the quiet passage of a wave that began years, centuries, millennia before. There is a gentle symmetry in this. The death of one star becomes the beginning of many. The shockwave whispers into the cloud, and the cloud responds with gravity, warmth, and the promise of new radiance. Creation and destruction in the cosmos are never opposites. They are partners in an endless cycle, each moment of collapse making room for a new moment of becoming. If you drift quietly through the regions shaped by the shockwaves of old stars, you begin to notice a gentle truth woven into everything around you. Nothing in the universe ever truly disappears. Matter is not wasted. Light is not forgotten. Even the most powerful endings, the collapse of a massive star, the dispersal of a glowing nebula, become the beginnings of something else. This is cosmic recycling, the quiet cycle through which the universe constantly renews itself. Imagine hovering near the remnants of a long-dead star. What was once a brilliant giant has now scattered its ashes through space. Not ashes of fire, but ashes of elements: carbon, oxygen, nitrogen, iron, calcium, the building blocks of planets, oceans, mountains, and eventually life. These fragments drift through the galaxy in soft, expanding clouds. They mix with hydrogen, dust, and ice. They join new nebulae, in rich new molecular clouds. In time, they become part of new stars and new worlds. The universe does not throw anything away. Even destruction is a form of distribution. As you breathe in, imagine these drifting elements gathering quietly into the dark, slipping into the folds of a cold cloud. As you breathe out, imagine them spreading back outward when a new star forms, radiant and warm, in gathering, out, dispersal. Your breath mirrors the cycle that has shaped every atom in your body. The sun itself was born from such a cloud, one enriched by stars that lived and died before it. The gold in your jewellery, the calcium in your bones, the oxygen you breathe, the iron flowing through your blood, all of it was forged in ancient stellar furnaces. Stars long vanished from the sky, left these elements as their gift to the future. In the cosmic cycle, nothing ends alone. When a star dies, its materials feed the next generation. When a nebula collapses, it carries within it the memories of past galaxies. Even planets break down and reform over billions of years. Comets deliver water to young worlds. Meteorites seed surfaces with minerals. Dust blown from one region settles in another, nourishing the next stage of formation. This interconnectedness is gentle, almost tender. Massive stars that burned bright leave behind heavy elements, giving future stars richer chemistry. Smaller stars that then quietly shed their outer layers in beautiful shells of glowing gas, adding their own colours and molecules to the cosmic palette. Entire nebulae collapse, form stars, are carved by radiation, and eventually disperse, only to help shape new nebulae elsewhere. Drifting through the quiet dark, you can almost feel the age of these particles. Some atoms in your body may have been part of long-vanished supergiants or distant red dwarfs. Some may have passed through comets, dust clouds, or even planets that no longer exist. Every piece of you has travelled through time on a journey billions of years long. There is a gentle comfort in knowing this. You are made of recycled starlight, of ancient matter that has been part of countless stories, countless lives, countless moments of creation and transformation. Nothing in you is new, and yet everything in you is unique. As you drift deeper into this cloud, rich with the ashes of ancestors, let the truth settle softly within you. In the universe, nothing is ever lost. Every ending enriches the next beginning, and every star's death ensures that somewhere, someday, another star will rise. If you close your eyes here, drifting in the quiet glow of this young stellar nursery, you may feel a deeply personal truth whispering through the dark. Our sun, the star that warms your face every morning, the star that anchors every moment of life on Earth, was once a newborn in a place very much like this. Long before Earth existed, long before oceans formed or continents rose, our sun began its journey inside a dusty, swirling cloud of hydrogen and stardust. Its story is ancient, stretching back more than 4.6 billion years. Imagine now that you're floating in that primordial cloud. The gas is thick with the remnants of older stars, carbon, oxygen, silicon, iron, mixed with abundant hydrogen. These elements had been scattered by supernova explosions long before our sun existed. They drifted through the galaxy, gathered in a cold, dark cloud and waited. Gravity began to weave them together, and slowly the cloud collapsed into knots and filaments, one of which held the seed of our future sun. Inside that knot, hydrogen gas began its gentle spiral inward. Dust grains collided softly, sticking together. Over time, a warm core formed, a protostar glowing faintly in the darkness. It was quiet here. No planets existed yet. No worlds orbited. Just a warm sphere gathering strength, swallowing the dust and gas that would one day define the architecture of our solar system. As you breathe in, imagine that inward motion, gas collapsing softly, the core warming. As you breathe out, imagine the glow spreading quietly outward, the early pulse of the sun's first breaths. In, collapse, out, glow. Your breath mirrors the ancient rhythm that shaped our own star. Around this forming sun, a disk emerged, wide, gentle, full of possibility. Dust collected into clumps. Clumps became planetesimals. The earliest seeds of worlds took shape, drifting around, the young sun in silent orbits. The inner disk, warmed by the sun's glow, formed rocky worlds like Mercury, Venus, Earth and Mars. In the colder outer regions, ices mixed with gas to build giants: Jupiter, Saturn, Uranus, Neptune. Even now, fragments of that ancient disk linger in the asteroid belt and the Kuiper belt, echoes of the solar system's earliest days. Our sun's early years likely mirrored what you've seen in this stellar nursery. Jets shooting from its poles, winds sweeping away its birth cloud, light slowly carving out its home. It was not always the calm, steady star you know today. It flickered, it flared, it grew, and after about 50 million years, a blink in cosmic time, it settled into hydrostatic equilibrium, shining steadily for the first time. Modern Earth, with its oceans and mountains and forests, was still millions of years away. There's something humbling about realizing that every breath you take is warmed by a star that began its life inside a dark cloud of dust, shaped by the same forces you've been drifting through in this journey. Our sun's story is not separate from the universe's grand tapestry, it is a continuation of it, a child of ancient stars enriched by their deaths, shaped by their remnants. As you drift through this imagined early nebula, let the idea settle gently. Before Earth had oceans or air or life, our sun was already practicing its light. Its story began long before ours, and it is still unfolding with every new dawn. Every star born in a cluster begins life with siblings, hundreds, sometimes thousands of them, all glowing softly within the same cloud of dust and gas. Our sun was no exception. More than 4.6 billion years ago, it shared its birthplace with a whole family of stars, born from the same enriched cloud, carrying the same chemical signature, shaped by the same ancient shockwaves. These stars were our sun's brothers and sisters, yet today not one of them remains nearby. They drifted away long ago, scattered across the Milky Way like childhood friends lost to time. Imagine yourself drifting through the young solar cluster in those early days. The stars around you glow in a soft spectrum of reds, whites, and young blues. They are newborns, bright-eyed, warm, eager, but still finding their place. They orbit one another loosely, held together by the faint grip of shared gravity. But even in this closeness, you can feel the restlessness of their futures. Star clusters, especially open clusters like the one the sun was born in, are temporary gatherings. Their time together is brief by cosmic standards. As you breathe in, imagine the young cluster pulling together, stars orbiting in a loose, harmonious drift. As you breathe out, imagine that harmony slowly loosening, the stars drifting outward, in, together, out, apart. The sun's siblings didn't remain united because the cluster itself was not strongly bound. Over tens or hundreds of millions of years, gravitational nudges from passing stars, giant molecular clouds, and even the rotating arms of the Milky Way began pulling the cluster apart. One by one, the sibling stars wandered off, each following its own trajectory. Some drifted inward toward the galactic centre. Others moved outward into the quieter outskirts of the Milky Way. Some may now be thousands of light years away, but astronomers wonder, where are they now? Because stars born in the same cluster carry similar chemical fingerprints, scientists can search for them by studying starlight. They look for stars with the same proportions of elements, the same mix of iron, magnesium, silicon, oxygen, and dozens of other trace materials. These patterns act like cosmic DNA. A few candidates have emerged, stars that may once have shared the Sun's cradle, but the search is ongoing. The galaxy is vast, and 4.6 billion years is a long time to wander. Imagine drifting through the Milky Way now, tracing the possible paths of these lost siblings. Some might orbit far above the galactic plane, following long looping arcs. Others might sit quietly in distant spiral arms, warming planets of their own. A few might have lived short, brilliant lives and died already, scattering their enriched materials into new clouds of star formation. The Sun's family is out there, dispersed, transformed, and unknowingly shaping new chapters of the galaxy's story. There is a quiet beauty in this dispersal. Even though the Sun's siblings drifted away, their shared beginning remains encoded in their light, and the Sun too carries the memory of that early closeness. The chemical imprint of its birth cloud, the motion inherited from its first orbit inside the cluster, the dust that still lingers in the objects that circle it. As you hover in this imagined space, let the idea settle gently. The Sun once had a family, glowing beside it in the first morning of its existence. Today those siblings are scattered across the galaxy, like sparks carried away by a cosmic breeze. Somewhere out there, perhaps many light years away, one of the Sun's long-lost brothers or sisters is shining tonight, unaware but still connected through the story of their shared beginning. Once the Sun left its birth cluster behind, it began a solitary journey, not alone in spirit, but alone in motion. For more than 4 billion years, our star has been drifting through the Milky Way, carried gently by the galaxy's gravitational embrace. This journey is vast, slow, and steady, unfolding through spiral arms, across wide bands of starlight, through clouds of dust, and into open stretches of quiet space. To drift with the Sun is to feel the deep, patient motion of the galaxy itself. Imagine now that you're floating beside the Sun, but not the bright star of today, the young Sun, newly settled into its main sequence life. It glows with a soft, pale light, steady and warm. Around it, the early planets are still forming. The solar system is a construction site of dust, gas, colliding rocks and embryonic worlds. Yet even here, in this busy cradle, the entire system is moving, slowly orbiting the centre of the Milky Way. The Sun makes one full revolution around the galaxy roughly every 230 million years. This means that since its birth, it has completed about 20 full orbits through spiralling arms and dark interarm regions. Entire ages on Earth have risen and fallen in just small segments of the Sun's galactic path. Dinosaurs lived and vanished during a single turn around the Milky Way. Humanity appeared only a fraction of an orbit ago. As you breathe in, imagine the Sun pulling gently forward along its galactic track. As you breathe out, imagine the spiral arms drifting past in slow, majestic sweeps. In, motion. Out, passage. Your breath mirrors the steady wandering of a star carrying its worlds with it. The Milky Way is not a still place. Spiral arms are not fixed structures but waves of higher density, like ridges in an ocean. As the Sun travels, it occasionally moves through these denser regions, passing clouds where star formation is active. Sometimes it wanders through quieter areas filled with little more than drifting dust. The solar system's environment changes over millions of years, shaped by where the Sun is on its orbit. These passages may have influenced life on Earth, perhaps through changes in comet activity or variations in cosmic rays, but the effects are subtle, and the Sun's journey remains peaceful. It does not collide with other stars. Space is far too vast for that. Instead, it glides in a smooth, stable path, guided by the Milky Way's gentle pull. Imagine now drifting alongside the solar system as it crosses the galaxy's arms, regions filled with glowing nebulae and young stars. You pass by nurseries much like the one that once gave birth to the sun. You see clusters forming, stars igniting, clouds collapsing, and the soft glow of distant stellar communities. Each time the sun passes through such a region, it witnesses again what its own beginning might have looked like. Then, as millions of years pass, the sun drifts out into quieter space, regions where stars are spread thin, where darkness reigns between gentle pinpricks of light. Here the solar system travels in calm isolation, wrapped in its own orbit, warmed only by the sun's steady glow. There is a deep serenity in this long galactic drift. The sun does not rush, it does not fear, it simply moves, patiently, quietly, carrying Earth and its countless stories with it. As you hover beside it now, let this motion settle into you. The sun is a traveller, and every dawn on Earth is part of its gentle billion-year journey around the galaxy. Even as you drift far from the nursery where stars are born, far from the nebulae and pillars and glowing clusters, a memory lingers in the quiet. It's a memory carried not in sound, not in images, but in the soft, persistent light that fills the universe. Every star that forms leaves behind an echo, not a physical trace, but a presence woven into the vast tapestry of the cosmos. These echoes are written in starlight, in the elements scattered through space, and in the gravitational fingerprints stars leave on their surroundings. They are the universe remembering. Imagine hovering now in a region of deep space, far from any nebula. The darkness feels honest here, wide, calm and unhurried. And yet, you are not truly in darkness. The faintest glimmer surrounds you, a background glow composed of light from billions of stars too distant to see individually. This glow is like the subtle hum of a great cosmic choir, each voice a star singing softly across unimaginable distances. The newborn stars you encountered earlier contribute to this glow in their own quiet ways. Their light spills outward, travelling for millions of years. Long after their birth clouds disperse, long after the protoplanetary disks fade and planets form, their photons continue crossing space, some eventually reaching the eyes of observers on distant worlds, some absorbed by interstellar dust, some roaming the void forever. As you breathe in, imagine this light gathering, travelling, drifting toward you across ancient distances. As you breathe out, imagine it continuing its journey, passing through you like a soft, invisible breeze. In, arrival. Out, continuation. Your breath becomes part of the motion of light. The echo of a star's birth also appears in the heavy elements it releases when it dies. The carbon in your cells, the oxygen in your lungs, the iron in your blood. All of it was forged in stars that lived and died long before the sun existed. Their ashes became the material of new worlds, new oceans, new living beings. In this way, every star leaves behind a contribution that resonates through time. Even gravity carries memory. When a star forms, it reshapes the patterns of motion around it. It nudges nearby gas, influences the paths of small bodies, shifts, orbits, and creates new structures in the disk. These patterns persist long after the star has settled into its stable adulthood. The architecture of entire solar systems, including our own, is built on these early gravitational imprints. Now, drifting through this quiet region, you might feel a soft awareness. You're surrounded by echoes. The light you see is ancient. The atoms within you are ancient. Even the empty space carries imprints of stars that once burned bright and have since vanished. The universe does not forget its beginnings. It carries them gently, woven through every corner of space. A newborn star's first light is never truly lost. It becomes part of this eternal glow, part of the cosmic memory that stretches through billions of years. As you hover in the stillness, Imagine the faint light of countless stars brushing past you. A whisper, a reminder, a soft echo of beginnings stretching across time. And remember, the stars you see tonight are not just points of light. They are echoes of creation, each one carrying a memory of a moment when darkness gave way to brilliance. You've drifted with newborn stars, wandered through nebulae, traced the soft arcs of magnetic fields, watched planets gather from dust, and followed the sun on its long journey through the galaxy. Now, as you let yourself settle into the quiet of this final moment, the story circles gently back to where it began, to that first soft glow in the darkness when a cloud collapsed and a star's light was born. Imagine yourself floating once more at the edge of a stellar nursery. The gas is still, the shadows soft, the silence deep. Pillars rise like ancient sculptures, and faint sparks flicker within them. You know now what those sparks are. Each one is a beginning, a warm core forming, drawing the darkness inward, gathering strength. Each one holds a future of light yet to come. As you drift closer, the first warm radiance touches you. It isn't bright, it isn't sudden. It is a gentle reminder of all the stars that have ever awakened. The young star ahead of you is just at the threshold of becoming, its glow barely visible through its cocoon of dust. And yet, even this faint light feels familiar, like a memory rather than a discovery. Because in a way, it is a memory. Every atom in your body has passed through cycles of collapse, birth, and transformation. You're made of the same recycled starlight that fills this quiet nursery. What you're witnessing now is not separate from you. It is your origin, written in cosmic language. As you breathe in, imagine gravity drawing the star's core inward, gathering warmth. As you breathe out, imagine that warmth releasing softly, preparing to shine in, becoming, out, being. Your breath mirrors the star's first emergence. You've seen how stars shape their surroundings, how their light carves homes in the darkness, how their death seed galaxies with new materials. You've felt how nothing is wasted, how endings become beginnings, how stars create stars, how light inspires light. The universe is not a place of isolated events. It is a continuous flow of creation and renewal intertwined across billions of years. And so, when you watch a star being born, you're watching the universe continue its oldest ritual. A ritual that has been performed countless times, in countless places, long before Earth existed and long after Earth is gone. It is the universe practicing its own form of breathing, inhaling in collapse, exhaling in light. As you drift gently through the last folds of the nursery, the young star's glow brightens just enough to soften the shadows. It is still early in its life, its winds quiet, its colour settling, its future unwritten. But the glow is steady, confident, certain. You pause and let your mind rest. In that warmth, this is how every light in the night sky began. This is how our sun began. This is how the universe continues. Quietly, patiently, beautifully. And as you prepare to drift into rest, let this final truth settle within you. The story of the stars is the story of motion, of change, of endless becoming. And you too are part of that flow. Everything flows. Sleep in that motion.